Ah, okay. All right. I need to reset this one because it's a different. But then we'll get it. Then it should be ready. And then we'll have to figure. We can figure it out later. But yeah, for some reason it's just not working properly. Now I need to reset this. Hmm. Oh, I don't know. Okay, I guess we'll just ignore it for now. But all right, let's start. Let's start. All right. So yeah, pretty much we're going to be working on programming today. We have a lot to do. So I've ended up figuring out the. I ended up updating the code a little bit off stream. I tried to not touch it as much because I want to kind of work on it on stream. One thing I did was I changed the name to Framer. Oh, actually, I can probably show you what I did. Assuming we tracked changes. There we go. Yeah, so pretty much what I did was I renamed the animation framer to just, or animation frame to just framer. I was trying to keep the same motif. I also made more of the items properties. This way I could, one, keep them private, but also if I need to do any modifications to them later, I can actually go in and do that. Also, one thing I did was, if you go over here to animator and such, you can see it's just basic renaming. So I didn't really change much. But now, one thing that we have to do, I've been doing is I've been thinking a lot about how to set this up and how to get it to work. And I think for the most part, I think we can just start messing with the animation, building the actual animation. Oh, why? What is going on? Oh, yeah, why does it say log into Twitch? That is an error that is an error. That is an error if I ever saw one. All right, let's try and reset that. Always happens. Always happens. Don't know why. Nope, apparently is that why is it asking me to log in? I'm literally streaming to it right now. Okay, I have an idea. We're going to pop the chat out. We're going to copy it. And then we're going to change it. Ah, okay. I do not know what is going on. I do know what I'm going to do, though. First things first, we're going to force it to go to a different website. Now that it's been forced into a different website, we're going to hop back. And no. Okay. I am literally logged in right now. Right now, I am logged in. Why is it asking for a login? I do... Let's try one more time. Oh! When things just don't want to work, they just don't want to work. And this does not want to work for some stupid reason. I'm tempted to say just screw it. We'll just remove the chats for now, but... Let's see here. Okay. I don't know why it's asking for a login. I really don't. There you go. Log in. I am literally logged into Twitch. I don't understand. This is the part that is so confusing. Maybe... I know what I'm going to do. I know what I'm going to do. If this is going to be a pain in the butt, then we'll just be a pain in the butt back. Let's see here. Where is it? There we go. Voila. We're going to jerry this up. Doesn't it feel fun to be just having to fix a problem that doesn't need to even exist? All thanks to crap. Alright, where is... There it is, this one. We'll go ahead and crop out all that at the top, because that's not needed. There we go. Now we'll get rid of the bottom one. There we go. Last but not least, we'll just move it on over here to our little window where it belongs. And it is good. There, perfect. There, good as new. You won't even know that I'm doing a window capture. As I said, I'm logged in. I don't know why it's complaining. So this is how it's going to be. But I digress. Let's actually program. Alright, so yeah, pretty much what I've been doing is I've been just doing a bit of organizing. Things have been situated. Now what we can start doing is getting into kind of the meat and potatoes, which happens to be the animator. Our sequencer is built. If you go to the sequencer, actually, something screwy is going on here. Oh, shush, shush, shush. Technical difficulties. Okay. All right. Let me reset this. Let's see here. Apparently we're having technical... Because earlier this in stream, this wasn't working. I thought it might have been the game. Because sometimes Identity 5 will just prevent you from doing anything on screen. So I kind of thought that that might have been the problem here. But I think this might be a bit more complicated than that. So what I'm going to do is I'm going to just restart it. And hopefully that'll solve our problem. There we go. Alright, yeah, there we go. That should have solved the problem. It just needed a restart, a refresh. Okay, any other problems that we want to have to deal with? Alright, we're back. Okay. Okay, I kind of see one problem. That involves my setup, the mini boxy setup. Move that up a bit. And that over a bit, like so. Yeah, the sizing's a little off. Alright, this works, this works. Okay, yeah, well, okay, maybe not. This is kind of annoying. Alright. There you go. Is that good enough? Yeah, that's perfect. Alright, good. Done. Okay, everything's set. Everything's working. I can type in now. There we go. Da-da-da. Okay. So let's actually work on this. So pretty much, now we're into the animator side of things. If you check out our sequencer, so if you go to self, you can see this is our sequencer. If you go in and check out the components that it has, well, not necessarily its components, but the animations that it has. So we type in animations. Actually, we're not outputting it yet, are we? Where's our loading code? Oh, here. So components, animation components. Oh yeah, we're not done with this yet, are we? Because the last thing we want to do is animations. And this is going to equal components. Like so. And to be fair, this needs to be attached to an emotion as well. Because this animations here happens to be a dictionary. And the dictionary is associated with an emotion, as you can see, right here. Add emote. Let's see here. So we add an emote, we update the sequence, we're getting a frame. Then we're loading in said sequence. So, why do I have a feeling that the code is it works, but it's not going to work kind of the way we have it set up. Because here we're loading up our directory. So let's see here. First things first, components. There we go, idle and talk. So there's our two components. So this code right here will generate this for us exactly. And this is, let's see here. Yeah, these are the two animation components. And then we're connected to the iter tools, which is our sequence loops. Yeah, there it is, iter cycle. So these are all set. Now we just need to output the components into its appropriate folder. So we add this, we're inputting in the component. Oh, why does it feel like this should be somewhere else? Yeah, it feels like that should be this right here, update sequence. Technically, we need to do that because we can modify the sequences here and there. Add emote. Oh, I have an idea. What we can do here is we can put in the path. We can put in a dir path. And we can also put in parameters, which will just so happen to be this. And both of those can be none. Oh, missing a P. Yeah, so both of these can be none. Now the general idea is that we're adding in our emote. Now if dir path, why does that have a th there? So dir path. If that exists, or alright, if dir path, so in other words, if it's not none, then what we're going to do is we're going to do self.load component, or load component directory. And then from here, we'll then simply put in our dir path and parameters. If parameters is none, then nothing should happen. So that should be perfectly fine. And if dir path doesn't exist, then it should just go away. So with this, we could easily load in our data. Now with that in mind, we should probably actually have this output a components. So, but I wouldn't mind inputting it straight into animations. There we go, something like that. This just means that this has to output our file now, which shouldn't be too bad. Let's see. Here, this is what ours... Yeah, this needs to, update sequence needs to be completed. Let's see here. This needs to be output. This is the main thing what we're doing. So this is going to be a dictionary. This is going to take the animation component. There's animation components, followed by an iterator. There you go, followed by iterator. There we go. And this is Framer. So yeah, that's our output. Nice. We should probably organize this a bit so that it's not taking up too much space. Man, this is a bit long. Alright, we'll just do that for now. There we go. Okay, so that's our output. And then last but not least, once we do the logging, then we'll return components. There we go. Nice. There we go. So now and now it's complaining. Why are you... Oh. We need to get this out of the loop. There we go. Alright, nice. So now that we have that set up, yeah, that is set up and squared away. The next thing to do is... Oh. So the next thing to do is go ahead and mess with this. So what we can start doing now is we can call add emote. We can pull in our various parameters. Or if we wanted, we could add emotes without providing the dir information or the parameter information. And then we could just slowly start updating the sequence as we move along. Yeah, I don't like this. I don't like it, but I want to get to the sequencing thing. I want to get to actually building the frames. So why don't we go ahead and say this is good for now. We can update it more as we go. But yeah, we now have sequence out. Now it is the animator. Time to do some animations and actually start building said animations. So we have, let's see here. So there's our sequencer. That's where our animations are going to be held. There's our counters. So one of the things that we thought about earlier was, because I'm going to be wanting to keep track of the sequences. Some of these animations are loopable, and some of them are, some of them can be interrupted and some of them cannot. And as such, we need to keep track of that. We need to know how long a sequence is, and we need to know what our loop currently is. So yeah, right now our active sequence is the animation components idle. And then we have our active counter, which will be going up. And then once we reach the end of, once we do a particular action, it will go back. Because we're using sequences, they will effectively loop forever. I think, yeah, right here. You can see it. You can kind of see it right here. It just kept going next component, next component, next component. And it just kept cycling what we want. So with this in mind, we just need to keep track of how long our animations are. And those that are interruptible, we can simply say, no on changing the active sequence. This will be our nice little loop. We can worry about warping and transformations later. Given how I currently have it set up, I think the warping might go back into the framer. I was kind of hoping to be able to do it during the animation step, and I might still be able to because we can apply a warping. But we'll find out. Let's see here. There's get frame. Here's a get frame where we go into the sequencer, we click get frame, we'll pick our emote, we'll pick the component, and then we can potentially reset the loop. Okay, get frame, sequencer. Yeah, we didn't write anything for get frame yet. So, yeah, we didn't really say what the frame is. Technically, we're just going to return. Yeah, technically, we're just going to return self.animations. Yeah, here we go. Return. Yeah, so return animations. In this case, I do, I could do a double get, but then that would lead to a potential problem. Granted, I think it should be fine. So what we're going to do is going to put here, this is going to be emote, and then last but not least, component, like so. And then from here, we're returning the next one, like this. There we go. Oh, let's see here. Oh, we're returning the... Oh yeah, we're not returning an image exactly. We're still returning the object. Because this should be a sequence. The best thing to do is... Okay. Let's see here, let's see here. We have components. Right here, components. There we go. And we want to input this into animations. Let's go ahead and do that. Self dot... Well, actually not that. Let's just call it animations. Actually, there is animation. So self.animations. And we'll put this in with the animation emotion. We'll call this happy. There we go. Wait, why does it say none type? Wait, did I not activate animations yet? Oh, I haven't. Oh, yeah, I haven't activated animations yet. So let's go ahead and do that. Let's see here. Where is initialize? I see new. And I see new, get instance. There's load composites. It is not here. All right. We'll put this down here at the bottom. All right. Self.animations will equal this. Self. The instance is fine. The main thing is the animations, because these are going to be associated to the single instance. So now we've activated that. Next on the list. All right. Next on the list would be that it would add it in. The first things first. Let's just go ahead and activate it. There we go, components. So now we go with self animations. There it is. So there's the happy animation, which is made up of the different components for talking and idle. All right, nice. Then the next thing what we're going to do is we're going to call it. So self.animations. See here, animations emotions dot happy. And then this is going to be animations components dot idle. That should bring back the it's the iterator. I was right, which means we could next this. Let's go ahead and next this. Next. I'm going to simply next our iterator. And there it, oh, and then last but not least, show. There we go. So all we're missing is the show at the end of our nice long list after the next. So if we type in .show here, there we go. That's our frame. And it is complaining. Expected a okay. Well, all right. You're just gonna have to live with that for now. But that's how we get our frame. Reset loop. We'll have to figure that out. Let's put that down in a to-do. So add in reset loop. Now the main thing is the animator. So when we do this, we'll get the frame. So now let's see here. OpenCV. If I recall, that was what we were originally going to use, was OpenCV. We're going to create a video buffer. They keep saying online that we should probably use a... Alright, I'm going to go with subprocessing. I know that for Python, it's best to use Asyncio, but I'm going to use subprocessing. Let's go ahead and hop on over to our guide. I don't use OpenCV, so I'm a bit... Yeah, I'm a bit green behind the ears. All right, right here. Yeah, if you remember, we were looking at seeing about using OpenCV as a GPU. Apparently, we have to initialize it with the CUDA module. We have to kind of build ourselves. So first, we're going to do is see if we just subprocess it, if that will be fine. If it doesn't work, then we'll have to find another way to reduce the amount of resources being used. But for now, we're just going to try and use OpenCV and see if the basics will be fine. All right. So let's see here. Where is our... Not image processing. Actually, it might be image processing. There we go. Getting started with OpenCV. There we go. Okay, maybe not that. Oh, come on. Where's the documentation? Just basic documentation. All right. This must be it. So we'll have to just kind of start digging through here. What we need to do is we need to find the basic... We just need to create a window. Just create a OpenCV video frame and then just start dumping in as many frames as we can. Ideally, what we can do is... Yeah, let's just get the frames loaded up first. The talking animation, because we have the talking animation, it should be fairly simple to just get that looping. Let's see here. We are on Ubuntu. We've already installed it. Actually, another way we could do it is simply input in, use tkinter and input in, update the frames. Actually, I did that before. That's not a wise idea. That just saps so much energy. Core operations, base operations. So cv2.read, yeah, that's to load it up. That's printing the image. Splitting, merging, we don't really need to do any of those. Oh, and they're going... I just saw... All right. I just saw something. Am I going to be using... Where are you? Matplotlib. I hope I don't have to... I want to try and keep it in Pillow. Okay, actually, you know what? Let's do that. Let's type in OpenCV Pillow. And see here. Create image header. Oh, here we go. NumPy OpenCV image. So we'll have to convert our current image to an OpenCV image. I kind of expected that as much. Oh, come on. Come on. Not video capture. Video, not a writer. What would you call this? What would you call this? It's not a writer, and it's not a capture, because capture means you're taking output signal in, and a writer means actually, it might be the writer. Instead of writing to a file, we'll be writing to a stream. Yeah, video writer. Yeah, actually, this might be kind of what we want to do right here. Video. All right. The best thing we can do is just try it. It doesn't hurt. It doesn't hurt to try. Let's just copy and paste this. Let's make sure that we have all our dependencies. Oh, they're already outputting it as an... Okay. Yeah, all right. They're outputting it as a video already, so we don't want to do that. We want to output it to a stream. All right. When creating a video writer, you need to provide several parameters. Extract a tutorial can be found here. And all right, that's the documentation. Okay. I don't know why people don't like Stack Overflow so much. I really don't. I've been seeing videos all over the place about how everyone seems to hate Stack Overflow. And I don't get it. I really don't. Maybe it's because of... I know that people say that they're very crude and blunt and they're not very friendly, but I always found them just being very direct. And they don't really ask much. They just ask you to provide a example that they could run. It even might, you trying to develop that might even help you solve the problem. There has to be a reason. Someone could probably explain to me why, but I never found any problems with Stack Overflow. Maybe I don't interact with enough people. Yeah, that's not what we want. Hey! How's it going? Parallel? I guess that's how you say it. Parallel. Anyway, how's it going? Right now I'm trying to figure out how to make OpenCV send out a stream. Actually, I might have to actually output it to something like Tkinter. Tkinter. How to show webcam in Tkinter. Yeah, we might have to actually do this. We might actually have to create our own little window and then output our stream to that instead of to a video. We're still going to be using video capture, maybe. But video capture is grabbing from another area. Yeah, I really... Pi image search is actually a very good repository for data. It's also very old. Let's see here. 2016. Yeah, this is when I remember using this 2016. It's quite a long time ago. Yes, OpenCV, read, then photo image. Pack, configure image, button, loop, pack. This will simply open the image. But what we want to do is open a video. Mainly, we want to print pictures to a video. Show a video in Tkinter window. Oh. Trying to scam me. You evil website. But it's definitely not a webcam. Oh, okay. I have a strong suspicion we're just going to have to start digging through here. I was hoping for a quick, easy solution. You know, we could just hop in and go, oh, pinpoint. Someone tried to solve this, but I have a feeling no one actually... If someone has, they haven't talked about it on the internet, or at least in the very brief search. So what we're going to look for is stream. Does OpenCV have any streaming modules? Video input with OpenCV and similar measurement. That might be it. Oh, and it's C++ code. So we're going to have to, we'll have to just convert it to Python once we need to, Let's see here, creating a window, moving it around, references. All right, that's not it. Online camera, offline file. No, no. Actually, is this, maybe what I'm thinking is, because I'm thinking of just, maybe what I should do is I should just start looping through the show out, but that's going to be very resource intensive, isn't it? Because these are opening live movies. All right, let's try this then. Let's try this. What we're going to do, oh, this is not going to be CV2. Instead, what we're going to do is we're going to change this. Say this is not going to be CV2. We're going to call this tkinter. TK or TTK, I guess you could say. We'll import in tkinter. All right then, and then from tkinter, if I recall, actually we should probably import from tkinter. There we go. So we're going to import TTK. Now for this, what we're going to do is, we already have get frame. That'll be fine. What we probably should do is define or load or display window. Now the window is, now we're not going to do anything with this thing here, but what we're going to do, let's see here, where are you? Frame. I think frame. Yeah, I think frame. Well, let's see here. Let's see here. Where's main window? There. That's not menu window. Main window. How much is not in TTK? It's actually in the main one. It's actually in the. Okay, yeah, it's in tkinter. We'll import both for now. And we'll get rid of the ones we're not using afterwards. tkinter dot. There it is. Oh, that's the main loop. Image. Ooh, image. So yeah, the idea is that we're going to create a display and we'll just start pumping in all our images there. If it's, hopefully it won't, we should probably subprocess this as well. So let's go ahead and import subprocess. Yeah, so we're going to subprocess this. That way it will not just consume all of our memory. Let's see here, subprocess. Let's see here, where are you? Not get output. Oh. Not get outputs. Not check alt call. I think it might be run. Well, that should be much later. All right. The main thing is we're going to start subprocessing this. First things first, let's load up. I have very limited knowledge with tkinter, so let's go ahead and just go check out the. Oh, actually, speaking of tkinter. Oh yeah, actually, speaking of tkinter, I was looking this up earlier. Okay, nice. Yeah, this is what we were looking at. So pretty much here, what they were doing was they ended up doing a label grid, so app frame. Oh, they just imported everything from tkinter. Okay, that that'll make things a little bit more confusing, but there we go. So TK is the root. Then they added in the background's going to be, we're changing that to, we're going to change the background to black. So first things first, let's just get it set up. Let's just get it set up, and then once it starts working, we will then go ahead and once it starts working, we will then go ahead and start moving files around. Get it work, then make it clean. Oh. Let's see here. So app is frame root.grid. Where did root come? Root is TK. Okay. So root is tkinter.tk. There we go. Then frame is going to be equal to the memory of a trout here. Frame with root in the background. All right then. So tkinter.frame. Oh. tkinter.frame. And this will be root and the background. Background is going to be black. So there's our frame that's open. Now what we already have is a function that will get our frame. So all we have to do is just call said function saying what we want, and then from there we can get it to work. So with that in mind, let's see here. We'll app.grid, and then we will bind the label to grid. I don't think we need to bind a label. In fact, I think all we have to do is just, well, oh, hey, I shall ban you. I love me some banning. There we go. And not only am I going to ban you, I'm going to report you too. Let's see here. You are a bot. You are a bot. Is a bot. There we go. There we go. Okay. Congratulations. The bot has been banned. Hey, congratulations. Okay. So let's see here. Let's see here. So define video stream. And then from here, we'll just simply read our frame. We will then convert it to a CV image. We'll then upload it. Capture is the video capture. So when we call cap.read, it's pretty much capture an image from the frame, but we're not doing that. We're going to use our getFrame function. So this is a replacement for that. It's right here. And then from here, they'll do image. This is, all right, here we go. Pillow image. All right, then. So from here, we'll do, they convert the CV2 image to a pillow. Then they use imagetk.photoimage to make a TK file. And then they can upload it to imagetk. All right. I don't see imagetk anywhere, though. At least not in the example that was written by Devash. So with that being said, that means it might be just a main part of the label. That might just be a label thing. Let's assume that it is a label thing. So yeah, let's just assume that's a label thing. So, and they run video stream at the very end, and then run loop, root.main loop. All right. Okay, if that's the case, then that means this top bit's going to let's just go ahead and copy, or let's go ahead and do these up here. So frame.grid, that, and then, okay, I'm going to move this over a bit so I can kind of actually here, frame.grid. All right then. All right, frame.grid, and then tkinter.app. All right, I'm gonna, you know what? Let's just I didn't want to do copying, but I'm just gonna copy and modify. That's what I'm gonna do right now. Just copy and modify. I have the brain of pudding, so I tend to forget things. All right, so lmain tkinter.label, there we go. And then from here we're calling this frame, so there we go. Now we don't have to worry about tkinter image right now. But that's to set up our frame right there. Then the next thing we'll have to do is create the loop. Let's just copy this. There we go. So first things first, this is not what we're doing. We are simply, this is simply our get frame function. This is simply get frame. And right now we're going to use our idle or happy animation and idle or talk. There you go. Because talk moves too much. It moves all the time. So there's our frame, and we'll even call this frame. Yeah, we should probably rename this to app. That way we won't get confused between the difference between the two. So frame, and because it's not a tkinter anymore, we don't have to do that. I wonder if we even need to do this. That's a good question. I don't think we need to even convert it. We can try. Let's see here, image TK. All right. Well, don't tell me. Okay, we'll have to import it separately. Let's see here. What was it called? Tkint image TK. There we go. Image TK. There we go. Oh, come on. There's a... Okay, where did image TK come from then? It's from Pillow. I see. Okay. Pillow has image TK. All right. Image TK comes from Pillow. So yeah, that explains why that's not there. But that does mean we'll have to... Image TK. There we go. So that explains what we... That's why we're using Pillow there. Okay. But actually, this is already a Pillow image. Most likely this is to convert the frame. So we'll go ahead and do that. And then from here, we'll then output these. So because of the fact that this is a video streaming function, I'm just trying to get it to work right now. So we'll do that. Actually, no, we won't do that. So main L will become... All right. All right, these can be all hard variables for now. Boy, there's going to be a lot of rewriting that yeah, there's going to be an awful lot of rewriting we'll have to do once we manage to get something just running. Because this is definitely not gonna, this is definitely not pretty. Oh yeah, definitely not. Oh, if I submitted this to anybody, they would probably look at me and laugh. There we go. And last but not least is video stream. And video stream is a self-reference. Ah. Alright. There we go. And then last but not... Now what is this complaining about? Unexpected parameters. Well, we'll find out. And then last but not least, here we will go, we'll need to run video stream. And then the main loop. So let's see here. Root.main loop. Okay. There. Oh. No. Main loop. Thank you. All right. Let's try this. And what's... Okay, there's an error. No module named tkinter. But what? There's a module named that. Oh, it needs to be capitalized. Or maybe not. Okay, what do you mean there is no... What do you mean there's no module? Module not found. No module called tkinter. But tkinter is a built-in Python function. Oh, okay. What, is it not? It's, interesting. That should be a default built-in function, though. Yeah. What is wrong? Yeah, tkinter. It's spelled. It's even spelled correctly. It's even spelled correctly. So why is it throwing an error? tkinter. Let's see here. What does the exact error say? Import failed. Home desktop Python dev import pydev hook failed to import. Module equals self-import name. No module name tkinter. Install package. Module not found. So it's a module not found error. I'm going to restart this. No, it really doesn't like tkinter for some reason. But why? It is a built-in function. Yeah, it's a built-in function. Why is it throwing an error? That doesn't make any sense. Could not find any version that satisfies the requirements, which again doesn't make sense because it's part of the library. Installing package feature. All right, let's try it. Did it work? I don't know. Hey, Bangladesh, how's it going? Nope, still throwing an error. All right, one more time. Well, I just said hi. All right, we're changing it. We're going to use something else. Let's see here. Instead, we're going to use PyQt. Let's see here. We're going to use PyQt6. And that one's also complaining. What is going on? Why are none of my functions working? PyQt. Oh, right. PyQt6. It's already installed. It's why? Maybe the maybe it needs to be capitalized. Yeah, there it is. Okay, all right. Okay, it needs to be capitalized. So instead, we're going to use PyQt instead of tkinter. I already said hi. I said hi, Bangladesh. I'm going to suspect you're a bot in a second. If you fail to respond. Yeah, you're a bot. All right, I'm going to ignore you. Let's see here, PyQt6. So now we have that installed. All right. We'll just simply switch it out for the other things. So instead of tkinter, we're going to change it. Let's see here. To be fair, I don't know much about... GUIs are not my thing. They're really not. Okay, I'm going to remove you. Well, okay, I won't remove you just yet, but you're on thin ice. Let's see here. But we're not going to use tkinter. Let's check out... Let's just go ahead and go here and type in PyQt6 and just create a basic window. There we go. Nice and simple. So the Q widgets. Oh, all right then. So we'll import in application Q widget. We'll create our first. Oh yeah, I remember the this. All right, yeah. So we'll create this, the Q application. Then we will go with. We'll then create a window with the Q widget, then show it, and then we can execute a loop with that. I think this should potentially work for our issues. No, not really a professional. I have worked on it quite a bit. I have been programming for 16 years, but I'm nowhere near a professional. I do know how to think my way out of a paper bag. At least one could say that. I know how to think my way out of a paper bag. I could tell with the name Bangladesh. It's kind of easy to point that you're from India. Okay then. So let's see here. So what we want is to make, yeah, so we're changing all of this. We're changing all of this out. So first things first. Yeah, changing all this out. No. Let's see here. So application system argument. Let's see here. If you know you won't be using command line arguments to control Qt, you can pass in an empty one instead. All right. Technically, we'll be accessing a lot of different functions. We'll be accessing the keyboard. We'll be accessing the microphone. We'll be accessing a whole lot of things. And from that, from that, what we'll then be able to do is make the character jump around and bounce. So I don't think this is not going to be... Ooh, actually, we might need command line. We might need command line. But, I think we do need command line. So let's go ahead and import in system arguments just in case. Because, well, you never really know. You never really know, huh? Hey, endless death. All right. So the animation pipe. So what I'm building is a simple animation pipeline for my little guy here. So if you look over here in the corner, you can see my avatar right here. And he can move around a lot. He can bounce. I can make him talk. I can move him around, so different different poses. And I have a lot of different emotions like angry, silly, sad, happy. Now this is, if you know anything about how to animate like this, what this actually is a series of videos that are being overlapped on one another. Pretty much, if you've watched Scout Falco, the YouTuber, you'll know he talked about something called a ToonTuber. And what it does is he made a thing called a ToonTuber, and it explained pretty much a general pipeline for animating this. Now the problem is that there's a lot of back-end development that needs to go into it. I need to generate all of these as individual movies. So for every one of these animations, there's 5 movies connected to it. It's the bounce at the intro, it's the talking animation, even the very loud peak is a movie. And I figured rather than having all of this minutia in order to just work it, I felt that one way to potentially help would be simply to cut out the middleman. Instead of making all of these movies, just take the images that I've generated, squish them together, and then just pump it into a video feed, into a streaming, into a video buffer. So that's actually what I'm trying to do. Nice example, if we look here, I can kind of show you an example. Oh, remind me later. Thank you very much. So if you look here, here's all of the individual frames. Yeah. It's quite fun. Yeah, I'm kind of new to to some of this as well. At least the trying to get this to program. But if you look here, you can see all of the different components to the character, and I generated all of these. And what I would like to do is swap them in and out, because then what I can do is, if I wanted to change the VR headset or something, then I could easily do that. And then if you look here in the sequence samples, these are all of the different parts to it. You have the talking animation, where if you look here, you can see that there's the high talking, the peak talking, and then there's the mid speaking right here, and then the idle, which means that it's not moving and such. And then likewise, there's intro and there's idle. And pretty much what I'm doing is I want to use these to generate a frame. Let me go over to the sequencer so I can show you what I mean. So here's our sequencer. Let's run it. There we go. And then let's see here. I actually built here it is. Load components directory. There it is. Load components. Oh, I need to tell it the dir path. And I probably should tell it the parameters too. All right, actually I think this is enough. There we go. Okay, now it is loaded in. So if we go to the sequencer and check out animations, you can now see that... Oh, it's empty. Let me output this. Components. There we go. So if we look at components, there we go. You can see there's the 4 animation points. We have our intro, we have our talking animation, we have the idle. And then when we call these, so let's go ahead and call one. So self, components. I'm currently writing everything out to use enums because I figured that would make it a bit easier. So animations, components, idle. There we go. So that's the... Oh. Let's see here. Sequencer has no attribute called... Oh, whoops. Yeah. Let's get rid of the self. There we go. So there's our iterator. I'll call that A for now. So A, let's go with next A. I'm just trying to get to the end. Okay, B dot show. And there's our pillow image right there. And I believe if I do it twice, there you go. Voila. There's our frame. And then all I have to do is I have to go to next, and then it will produce the next frame, and the next, and the next frame. And pretty much I will have, I can animate them just by calling these different frames. So the idea is that once we get to the frame here, we can then feed it into our... It was originally going to be an OpenCV buffer. However, one of the big issues is apparently OpenCV just wants to save the files or not. I wanted to actually create a streaming window where, open up a small window. We'll have a... Yeah, I want to open up a small window. I'll have a... the animation playing out on it, and then I can just feed it into like something like OBS. And then based off of different commands that I send, for instance, hitting a keyboard or because the talking animation is all based off of audio volume, so I will have to import in the microphone settings at some point. But the idea is that once we have those, then it will just modulate what frame is being grabbed next. And right now we're trying to build the animation part. Hence, it's called Animator. And as I said, OpenCV doesn't seem to want to do it. So now we're looking at... I was going to use tkinter, but apparently... I don't know why. Yeah, I don't know why. It claims it doesn't exist. It's just not... tkinter's just not existing. So we'll use PyQt instead. That will put a bit of a bind, though, because if I recall, in order to have the application open, we have to... In order to have the window open, we have to run app. Maybe... So, how much do you bet our application here that we're doing, this entire thing, the animator, it might actually have to... We might actually have to import in PyQt widgets. So we might have to import in the Qt widgets into here. Yeah, I think that's what we'll have to do, because once we do this, then theoretically this means that we'll also have access to some of the calls. There's a lot of call buttons in the in PyQt, and we need access to those, especially if we're going to do anything GUI related. I don't want to really do anything GUI related, but it's there if we need it. Plus, I probably might need it. Now, because of this, we're going to have to... Yeah, because of this... Alright, well, let's go ahead and load up our... Let's go back to the guide. Yeah, we can show the application, we can create the widget, and we can show. That should be very simple. Now, the question is does PyQt6... we're not actually loading a video. We're just going to be modifying a particular frame. This is one reason why I was thinking about video buffer. Let's see here. Stream image. I highly doubt this will come up with anything. I highly doubt that will come up with anything. So for this, what we're just going to do is PyQt6 image. There it is. Documentation. Q image. That's what it's called. Cache key. Color. Oh, they have... Apparently we can modify the color of the images here. Oh, oh, does anybody remember a really old... Well, okay, maybe not that old, but there's an old game that came out a while back. It was called Tsundere Simulator. Yeah, it's called Tsundere Simulator. The reason why I bring it up is because it actually, kind of referencing the code, is actually poorly programmed and poorly optimized. Apparently, the way, as the person developing it went along, he kept finding newer ways to do certain features. So one of those was, if you wanted to change the character's looks, then you could actually apply cell modifications to the model. You could change the, it's an actual shader kind of overlay. And it would work great because you didn't have to go in and modify the textures or anything. However, because this was a layer, extrapolated out, it pretty much meant then that anything that if you modified there and then you went back and modified the original texture, then you would end up getting some very weird hiccups in the graphics. I feel like that might be what happens here if I try to do pixel manipulation on an image that's already being modified. Like, this would be 2 layers of manipulation, which we kind of want to avoid. I just want to display an image. That's all we want to do. I'm wondering if, let's see here, convert to, copy. This is moving it. Boy, PyQt6 has a lot of things similar to Pillow. Flip, format, static, load file, load device. Oh, load device. An IO device. Actually, that might be what we need to use. Because I remember using IO devices for storing images in memory. But they're kind of already being stored. Yeah, we kind of already have them loaded, so probably don't need that. Oh, this is all image manipulation. Yeah, this is all image manipulation. I just want to load the image. Set pixel, get pixel. All right, it has to be at the very top. Let's see here. And the answer is no. Okay. No. All right. Display image. How to display images. PyGUIs. All right, here we go. Window load UI. Main menu dot UI. Yeah, well, that's not what we want. Pixel map. That's not. Oh. That's. Oh, here we go. Q pixel map, and then we do the. I wonder if we can. This will work then. Set pixel map. I don't think that would be it though. I really don't. We can try. Let's see. What he does is create a main window. All right, he's creating a main window. He then will initialize it down here. There's the execution. All right. How about we just fiddle about? Why don't we just do that for now? Yeah, let's just fiddle about. We'll copy this. We'll create a new window here. We'll call it something like, there we go. This is test ground. We don't need to copy. We don't need to track this because we're going to be dumping it as soon as we're done. The main thing is here. We already have ourselves our image. It's called B. So let's just copy this here into the QMap and see if it will load it up as a window. And if I recall, it will crash if I call, oh, let's see here. What is this? What is this complaint? This application failed to start because no Qt platform plugin could be initialized. Reinstalling the application. Reinstalling the application may fix this problem. But, okay, but why? It is over. The joys of Python. And it crashed. And it crashed. Okay. All right, let's restart. Okay, I'm just going to load this up first. Yeah, that's... Could not load the platform plugin XCB in a node. This application failed to start. Available platform plugins are all of these. All right then. I guess maybe we'll have to try and reinstall it. Let's see here. Pip install upgrade PyQt6. There is an update. There is an update. I wonder if that will solve our problem. Let's try again. Nope. Still same error. All right then. Why? Who would have thought that a basic install would crash? This is so very confusing. Let's see what this error means. I'm installing, reinstall. Let's see here. Sudo app. Okay, so I guess we should install Cursor Dev. This fixes the problem. Okay. It doesn't explain why we're having this error, though. Oh, is it because I'm using Ubuntu? All right, well, let's go ahead and install Cursor Dev. That might solve our problem. So let's see here. Yeah, we'll just copy this. We'll copy and install this. There we go. And there we go. Okay, there. Unable to locate package. All right, that didn't solve it. Why are you the way you are? I wonder if there's a way around this then. Not load the QCB. We could try installing just libxcb. For anyone running into this? All right. Well, yeah, I know I need to install the libraries. I guess we'll just try and install the we'll just sudo app install libxcb. That might solve our problem. There we go. Okay. Now we just play the waiting game for that to install. I guess while we're waiting, let's go ahead and reload up our animations. Oh, actually we should wait. We should wait for this to finish. Oh, it's done. All right, nice. Now, will you work? And it did work. Okay. All right, now that that worked, let's load back up our sequencer. All right, there's our sequencer. We'll load up our... Oh, we need to do the dir path. There we go. Oh, I need to set this out because we currently don't have it set anywhere. So components, then components, and we'll go for the idle. There it is. Next in the list. So there it is. There's the first element. We'll go ahead and do that. A will be the second element now, but now B will be, let's see here. So A happens to be our frame. So A.show. There's our frame right there. Nice. Which means that this right here, B, this should be B. And there we go. There is our image right there. So with that in mind, let's go to testing ground. We don't need to worry about the .show. We already have our image loaded. So let's go ahead and run this. Okay, we'll run that. And then we'll run these. Oh. Let's see here. Argument unexpected type image. So QPixelMap is... It did not like the image. I'm going to just put B right here. I wonder if we can just bypass it like that. Oh, it needs the... let's not even worry about resizing it. We just want to get something loaded. And, alright, it has a complaint. Unexpected type image. Alright, so we do need to modify the image in order for our system to acknowledge it. So what about QPixelMap? What does it take and can it use? So it can take in pixel maps, lists, It can take in a auto code. So this is all Qt stuff. Doesn't say anything about an image file though. Actually, it doesn't even say anything about a matrix. I see colors and numpy, or no numpy. Yeah, oh, here's image. Convert from image. But the convert from image is a Q image file. So if that's the case, then in this case, they're just taking a JPEG. Ah, I know what the Q image. Okay, I know what Q image is doing here. The QPix map. So what we'll want to do is, instead of just display image, it should be pillow to. We'll type in image. Image Qt. Ooh. This will creates an image Qt object from the pillow object. This is exactly what we need. All right, nice. So we can just use image Qt and convert it directly into the ib format that it needs. That will actually help speed things up. So if that's the case, then what we need to do is go to testing ground. So this will be image Qt. Oh, let's import that in. There we go. Actually, if I think about it, let's take a quick peek at that one more time. Yeah, it's just image Qt, and then you take an image in, and then it will convert it into some kind of file that can then be read. So we don't actually need to load up a pixel map. But we could try though. Let's just try it first and see. And yeah, it doesn't like it. Okay, why did you not like it? Did you mean image? No, we wanted image Qt. Because B is our image. Yeah, it's a pillow image. Image Qt. Oh, let's see here. This was an error here. I was just trying to convert it. I wonder why it's complaining. Yeah, it's just complaining. What, am I not using it? Am I not using it right? But let's see here. Image Qt. Oh, we already were in there. Image Qt to pixel map. Here we go. Oh, I see. I see. Okay, image Qt.image So we need to import in, or we need to use the other. It's not a. All right. Image Qt.image That should solve our problem. All right. Okay, let's try this again. And no. Okay. What? Why don't you? Why are you? What? No, I. Let's see. imageqt.imageqt.image. We're doing that. Look at that. imageqt.imageqt and then our image. I wonder why it's messing up. It says here that main window. Error name. ImageQT is not defined. But we defined it. Right here. It is defined. Right here. I defined it. It is defined. Why do you not acknowledge that it is defined? Oh, all right then. Okay, now it's working. And then now hit, okay then. One argument has an unexpected image Qt file. Why is this causing this? Let's see here. From image QM. All right. From image. So I guess that, or let's see here. First things first. So we have our image. We convert it to the Q image. We then will go into the GUI, select pixel map, and then from image. In this case, it will be label. All right. So I believe maybe here. Or let's see here. Let's see here. Are you doing GUI pixel map from image? In our case, we have label. I wonder if this has that as well. So we have from parent, from global. Those are maps. We're looking for Qt. Let's see here. Pixel map dot from. Let's see here. Apparently that doesn't have anything. All right. Q pixel map. Okay. There it is right up here. Q pixel map right here. So in other words, we most likely have to input it right here. So pixel map dot from image, and then this will be, we'll call this QIM, kind of follow the same structure that they have, QIM. And this will be our pixel map from here. Oh. All right. Now, will that work? Is that enough to solve our problem? And the answer is too many arguments. Too many arguments now. And this is pixel map. Label pixel, this one. Okay, I think we're going to actually have to just sit back and read some of the documentation rather than just trying to brute force this. We probably should sit back and just read the documentation. I was kind of hoping that we could just throw it together and it'll be easy, but apparently not. Apparently not. Well, or 1 second. All right. I was just checking something. So we already have our image, and we're currently at this point here. And all we're trying to do is output this to a label. So this PM is our pixel map. So that right there is our pixel map right there. So if we go back to our previous example, which happens to be somewhere. I don't know where that example went. Oh, actually, was it this one? Yeah, here it is, this one. This example right here. If we go back to this one, so we have our pixel map right here. We then load it into the label. Here we go. We need to set, so yeah, we need to fix our code a little bit. We need to set the pixel map for the label, like so. So we take our image, we then run it here, and then afterwards we then will proceed to do the loop. We could put let's just get it up and running first. Let's just run this. And of course, it's still complaining. Unexpected type, Q pixel map. Oh, okay. Unexpected Q pixel map. It's probably because it needs to be the label. Okay. So we'll set the label to center, like so. Run, and then run. Finally! Oh, finally, we got it! All right, we have it. We have our image up. There's a little bit of scuffs here and there. You can, I think those might just be my my poor drawing skills. There we go. He is up. Okay. And it crashed. Oh, maybe we'll have to set up a way to close it out once we're done. But now that we have that, okay, let's. Now that we have that, let's try and figure out more. Try and figure out more. The idea is to see if we can get it to loop. So let's go with that. dir path. There we go. Self dot. Oh, we want to put a components here. There we go. Now for components, let's go ahead and get our idle or let's get the talking animation. There we go. We'll call this AA for our testing grounds. Now that we're here, we don't need to initialize this anymore. So yeah, we don't need to initialize this anymore. What we need to do is we'll need to, because the label is the label is going to be static. So we'll simply create this. So we'll have self dot label, and we'll equal Q label dot self. There we go. And then these pieces right here will be in their own function. So this will be animate. And then from here, what we can then do is we'll take in a function. Why don't we just pass in AA right now? Let's see here. Let's go with while true. We'll do next AA, and this will be B. This will be B. And then we simply do this. I don't think we need to worry too much about the resizing of the widths. So let's just go ahead and remove that. And we'll set label like so. And then here we probably don't need to. Okay, we'll do it for now. We'll do it for now. So that's animate. So now what we do is after we initialize, then we animate based off of what we pass in. So in this case, we will pass in AA. And we'll, here go, AA, right there. There we go. Okay, perfect. This should work. Let's give it a shot. Nope, there's an error. Okay, what's the error? Let's see here, Qt image, assert instance. Assertion error, okay. Oh, oops. This is supposed to be B. All right. Yeah, this is supposed to be B. Let's go ahead and rerun this. All right. And another animation error. I wonder why. Maybe we need to do .show? Oh yeah, because we're not actually outputting an image yet. All right, and it looks like it might be running. Why does it look like I crashed it? Oh, I think I crashed it. Where's our frame? How much do you bet I should show it first and then animate it? Let's do that. Let's do that. I'm gonna go ahead and remove that. W.show w.animate. Okay. Let's go. And it complained. Let's see here. Oh. Yeah, we need AA in here. There we go. Okay. Did you see the window? Oh, here it is right here. Oh, I think I might know what the problem is. It keeps constantly writing and writing. There needs to be a pause in there. Pretty much, we need to define we need to give it a rest. So why don't we try it? Let's crash it. Okay, let's crash it. Yeah, it's trying to run like at 300 miles per hour. So we should probably put in here a timer. So time dot or let's see, a time dot sleep. We'll sleep for a second. All right. We'll go ahead and run everything. It might crash. Yeah, it crashed. Okay. Let's redo this. I'm going to have to write it up so it won't crash like that. And then from here, we'll go with components. There we go. Oh, we need the dir path. Components. And then when we run this one, we can run it the first time with not much trouble. AA. Oh yeah, we forgot. AA is equal to that. There we go. Now let's try. Okay, and it's kind of working maybe? I bet I need to resize it. Oh, PyConsole not responding. Wait. No, it should work. Let it wait. Come on, you can do it. You can do it. I think it might be too big. We might need to resize the image a bit. It's just having a lot of difficulty. All right. Let's crash it. Okay. All right, let's put the resize back in. If you remember earlier, we had remember earlier we had this resizing in. That might help. And this is exactly why I want to punt this off to a sub-process. Okay. So where are you, image viewer? Well, it's definitely the size. And it's not animating. Oh, actually that's still in the way. Okay. I'm gonna have to do something about that. I keep forgetting. Either way, the animation viewer is not working. It's supposed to refresh the frame every second, but apparently, yeah, it's not doing that. It's not doing that, and I don't know why. Okay, crash in Python. Do you think that it would be correct while true, we just cycle through our animation and upload a new image every second? And then from here, we simply run show animate and then this. The problem, I wonder if I'm going to have a button at the bottom to start it. Because originally we had the animation right here. We had animates within our right up here. But it did not work that way. Yeah, it failed to get to the showing the window. Yeah, that's not working. That's not working. All right. Okay, let's look it up. Okay, so using a window like tkinter or pyqt and then just constantly updating the frame doesn't seem like it will work. So what would be another way to do it? As I said, I thought about using OpenCV. How to read a video stream or offline file. Let's see here. We might have to use OpenCV. Essentially, all the functions required for video manipulation is integrated in video capture. This on itself holds the FFmpeg source library. I kind of knew we'd be using FFmpeg. This is a basic dependency of OpenCV, so you shouldn't need to worry about this. The video is composed of a succession of images. We refer to these in the literature as frames. In case of a video file, there is a frame rate, specifically just how long in between the frames. While the video cameras, usually there is a limit. You can digitize per second. This property is less important in it, as at any time the camera sees the current snapshot of the world. So yeah, we're not doing it on online camera. We're doing an offline, not even a file, it's an offline memory registry. First task you'll need to do is assign video capture class as its source. You'll need to either use a constructor or its open function. If the argument is an integer, then you will bind the class to a camera or device. The number passed here is the ID of the device, assigned by the operating system. If you have a single camera attached to the system, you can use 0. If the parameters passed to these is a string, it will refer to a video file, and the string points to the location of the file of the name of the file. For example, to the upper source video, megamindbug.avi. Okay. So I wonder if I could, well, Again, this is looking for a file and is going to go directly to the file and then it will load it. That pretty much means that we will, well, as I said, we're going to be loading said file and running it. Not what we need, unless we want to create a temporary file where we'll just dump frames into it and then we'll have OpenCV open it. But I don't want to do that either. Let's see here. We do a check for a reference. So no. Image similarity. So PSNR. We want to check. Actually, no, that's not it. That's not it. That's opening the video. So yeah, that's all right. So maybe what we should look at is, let's see here, Pillow to OpenCV. Open to OpenCV. If we do this, then how to convert from Pillow to Open. Oh, we were just looking at that. And it looks like CodeSpeedy stole this question. Same did LinDevs. And CodeRaven. Oh boy. Let's see here. Oh, I know. Instead of Pillow to OpenCV, Pillow to Video Capture. CV2.video capture. There we go. This is kind of exactly what we're looking for. This is the question. Let's see here. All right, here we go. You can mix Pillow and OpenCV. There are 3 ways to do this. You need to know. Convert to an OpenCV image into a PIL image. Yeah, so image from array, yes. Convert from a PIL image to OpenCV. NP array, and then we take the PIL image. Lastly, OpenCV stores images as BGR order, while Pillow uses RGB. So reds and blues will get swapped if you don't watch out. Use the CVT convert. Well, yeah. Let's see here. Well, let's see here. The main thing is the video capture. So we set capture.read. Oh, actually, let's see here. Well, that's loading up the movie. That's loading up our movie. We don't want to load up a movie though. That's the problem. Okay, so maybe this isn't This isn't the silver bullet we were looking for. Let's see here. No, no. I can't be the only one who asked this question. I really can't. You would think... Yeah, you would think that this would not be a difficult question, really. All I want to do is push an image. So let's see here. Video capture. Yeah, it loads up a video or it loads up a... Let's see here. Video capture. Load a... pillow file. No, no. Oh, come on. Okay, assist me. All right, AI, trying to help me. To work with image, you would typically use a pillow library and manipulate the image. Nope, it does not know what I'm asking. All right. So why don't we try this? Pillow. I kind of wish if I'd know a spot that I could ask questions, because I don't really know where to ask. I can read up on the only option is to just continue going through. Spend now just reading through all of the documentation about OpenCV and see if it has any potential solutions. Let's see here. Video input with CV. I think that might... Well, actually, that's what this is here. How to read a video stream offline or in... Yeah, we're kind of looking at... That was down here. So I have a feeling... I have a feeling we're going to have to actually create a video buffer. And of course, I picked a very... Oh, this shouldn't be too... I thought this shouldn't be too difficult. Oh, I just connect Pillow in OpenCV and I can have this file up and running perfectly fine. Apparently not. Apparently not. Oh, no. Let's see here. So why don't we try this? IO stream. Well, actually, technically Python doesn't have IO stream. Yeah, Python doesn't have that. Yeah, I'm trying to think of a potential documentation we can find in order to answer this question. I can't really think of any though. Oh, maybe what we should do is, instead of focusing on the anime, I'm going to probably have to spend some time reading about the animator. What we should probably do is focus on getting the sequencer done. That's something at least I can do, because I have pretty good knowledge in writing backends. And when it comes to the GUI and the OpenCV video animation, I'll probably have to read up on that. So we might end up having to put the project on hold a bit while I try and learn what to do. Unless somebody can magically just appear and say, this is how you do it. I'm going to have to read up on how to convert a Pillow memory file, which is, You can see it right here when I type in AA. Oh, sorry, not AAB. All right, when you type in B right here, dot show this right here, this pillow image file. As you can see here, I know how to get to here, and I know how to modify these, and I know how to export it into a video. But getting it into a stream is, not easy. So yeah, let's just continue working on the sequencer for now. Sorry, animator, we're going to have to ignore you. We're going to have to ignore you. So let's see here. So while we're at it. Alright, so we have add emotes, directory, update sequence, where we can update get frame, which will go grab us the image that we're looking for. We can just call the sequencer get frame. We have load components, which is fine. Get sequence. Here we go. There's a bug where dir look points to the other direction directories, but no image files, producing an empty frame. We'll have to fix that. And these are just our animation point, or our animation time loops. Let's see, framer. Let's see here. Framer. Any complaints here? Well, we have image transformation, layer components. This is the equal sign. Actually, we don't need this now. Originally, we were going to equate the two together, but we already figured that out, so we don't need that. Let's see here. Yeah, the calling of it is still having a bit of issues because it's not outputting what I want. Well, this requires a string. Horrible sorting, lose data if... Oh yeah, let's go ahead and rewrite this real quick. So the idea is this is supposed to be our sorting mechanism. When we want to restructure the layers, we will sort them. So we should probably put in a fix here. So first things first. We have our list and we have our layers. So let's see here. This technically should already exist in the form of B. Yeah, here we go, B. So let's go to components. There we go. There it is. There's our different components right there. And each of these components should have a name associated with it. Yeah, there it is right there. You can see name, image name. So what we'll do is we'll create a list of names. So self.get layer name. There we go. Get layer names. I wonder. I'm tempted to sort the two lists and then compare the two and see if they're equal. Because if we did that, then that way it would solve most of our problems. Let's see here. Is there a sorted? Yeah, here we go. Sorted is equal to sorted. So we're going to sort the layer names. And we're going to sort name list. Now, if these are not equal, So if these are not equal, then we're going to simply raise an exception error. Or, sorry, value error. Which will simply state name list or name list missing. Oh, I know. Instead, we'll just call it list missing names or list missing layer names. There we go. And that should solve that problem there. All right. Next on the list is make this more make this less Python-esque. Yeah, I think I'll worry about that later. Fix layer bug as all layers equals 0. Oh yeah. Is that really a bug though? With the way we have it set up, I don't think it's a bug now. Yeah, I don't think it's a bug now, so I'm just gonna remove that. That's now a feature. Here we go. Make more dynamic. So this happens to be here, the get the colorize. So yeah, we need to make this more dynamic. The idea here is that we were going to colorize it based off of the... Yeah, we're going to colorize it based off of the map. So if I remember, we already modified color map. Yeah, we already modified it a bit here and there so that it should work fine. We need to finish modifying here because this outputs a matrix of 3. And not all of them will be a matrix of 3. Some might be grayscale, some might be, some might be RGBA, some might even be binary. So because of that, we should probably, if you pick a binary and go with RG and say red, it should still output a binary image. So let's go ahead and let's see here. So first things first, if the instance happens to be a string, we're going to get the RGB like so. So we'll call this RGB color. And this will simply be an image color. There we go. Actually, is it going to be an image color or is it just going to be something else? It's always good to make sure our typing is correct. Red. And it's not. It's not. If I type it, it's going to be a tuple. Yep, it's a tuple. So, and it's a very basic tuple, mind you. Oh. It's an 8-bit tuple. I wonder if I could change. Okay, I'm now curious. Image color. Can I change you to be something more than 8 bits? Oh, it's not gonna show me the internal functions. Okay. So, image color. You have get RGB, image, get color, LRU cache. Oh, that looks like it might be it. Yeah, I think that's it. All right. If that's the case, then... Oh, if that's the case... Oh, maybe I should prevent it from taking in... Maybe I should prevent it from taking in names then. Because this is more of a... I'm gonna filter that out. Because that is, yeah, that's going to cause a lot of trouble right now. So instead, what we'll do here is we'll assume that it's going to pull out a tuple. Our color map is going to pull out a tuple. And what we shall do here is... So the color map should be fine. It's this right here, the black. So tuple, a list of zeros. This will be multiplied by the length of color map. There we go. And then color map already is dynamic. So there we go. Solve that problem. Okay, solve that problem. And then we have GS image. Okay, da 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 da. All right. Okay then. Seems good. Seems good. We have warp, colorize. I know I have show, which we send out a composite image. But maybe I should change that a bit differently. I don't know. Let's see. Add components. Add component. Add components. Add layer. Add layers. Let's see here. Image. Open image path. Oh yeah, we're setting it so that we just generate the paths and then we can load the images later. So we don't need that now. I kind of like the way we have it set up. To do, make less Python. Oh yeah, we're going to just ignore that for now. We'll go with all the Pythonisms until it starts causing a trouble. All right, channel check. All right. I believe channel check should be being called down there. Yeah, right here. Channel check. Make sure that, see how many channels we have. All right. Okay, and then we have bit depth, compile. In this case, what we're looking for is the colorize, the warp parameters, checking to see if the layer is even visible, image size, background color. Wow. Why does it feel like the framer is done? It looks like framer is done. Yeah, we do have that to do right there is just to remind us to change it later. So yeah, that is done, which means the next one is the sequencer. Oh, we're getting dangerously close to just having the work purely on the animator. Oh yeah, we're getting dangerously close to having the work purely on the animator. So here we go, frame comparing. Loading the sequences. Oh, there. Oh yeah, we need to work on that bug. And actually there's a lot of these. What is the complaints? Oh yeah, that one's fine because we were using none. Here we go. Expected a... Oh, I see. It's expecting a different type. And instead it got this. And then that means the same thing. It expected a... It expected this, and instead it got that. And then here is our quarks, which is not compatible with an int. Oh. All right. That means, that means we should probably, once we create the new one. Yeah, once we create the new one, we'll have to set this. Set our animations. Like so. There we go. And then we can start saving our animations proper. All right, let's clean up. Actually, why do I have a feeling that we're actually... that this is also kind of done? we have our adding the emotes, where we just type in our emote, our directory, and parameters, and then it'll load everything in for us, assuming that we did that. We can update sequences just by building the sequences we want and then adding them to the set animations. And we can get the frames. We don't... Oh, reset loop hasn't been done yet. Yeah, reset loop. Alright, if that's the case... Yeah, we should add an... We should put a to-do here so that we know that. We can kind of worry about the resetting once we get... Yeah. We're stuck with the frame. We're stuck with the animator. I thought we could... There's other stuff that we need to work on, but apparently it's this. Yeah, apparently it's this. So... Oh, and the... And usually the research into these things isn't the most interesting part. I could look at this for hours, but most people get bored just going through trying to learn or trying to figure these things out. So let's see here. Pillow, Python, stream, video. Not capture. No, not capture. We're not capturing. This has nothing to do with capture. In fact, instead of stream video, we should say stream images. How to stream simple images using streams in Pillow. Ooh. Bits.io. That's actually what I was thinking. Because this is how I was originally... One of the problems I found with converting images to binary, especially when trying to store it within a database. So I would use MongoDB to store images. And in order to do that, I would load up an image in Pillow, convert it into a binary, and then from a binary, I would then store it into MongoDB. And then when I wanted said image, I could then just go in, load from MongoDB, and pull it out. And to do that, I would use this io.bits. That was my way of converting the image into a format that I needed, or to use. Let's see here. Yeah, string.io and bits.io. All right then. Make sure you call buffer.seek before reading any string IO. Otherwise, you're reading from the end of the frame buffer, which will look like an empty file, as it's likely causing the error you're seeing. So we're going to create a string. We're going to create a buffer called string.io, or the string.io. We're then going to write our JPEG to said buffer, and then we will buffer seek 0. From here, we will then open our buffer and print the image. But he says here that they show that there's an error. Cannot identify. Oh, cannot identify image file. Okay, yeah, that's fine. But this is Can we attach the buffer? Can we attach the buffer to tkinter or to PyQt? Because the image is already in memory. We don't need to write anything really to a buffer. If we can attach the string IO to a window, then that would solve most of our problems. All right, I'm going to keep that open. Let's see here. So maybe that's what we should be looking for. PyQt string IO video. Not to string IO. No, the other way around. Video streaming in PyQt. There we go. That's kind of what we want to do. So let's see here. create a GUI. All right. Oh. All right. They know. Let's see. We did create it. Maybe it'll say something if we look here. That's installing the functions. That's then loading the designer. And no, that doesn't explain anything. Let's see here. Can we save a QMax to a Q buffer and then read it into string IO? That's not what we're trying to do. A simple PyQt output widget that is used for debugging. A video player. Ooh. Yeah, this might be it. This might be it. Video player. Well, that's a lot to create said video player. Open file right here. And then play. All right. This is the full video. All right. Maybe that might be what we have to do. Create a video player. Create a video player. Tell it to start playing. But the main thing here is opening the file. Because here they want a dir path. But I wonder if we can pass in the string IO as the file path. Let's look that up. So PyQt6 string IO as file path. No, not the dialog. Maybe OpenCV. Doing research for this thing. This is it. I wonder how many people have tried to do this. Well, that's for managing data file, but no, we want to... Because the idea is that we want to create in memory, we want to create a temporary location which OpenCV or PyQt can access it and say, this is where the images are. And then I could just dump the images in there and then OpenCV will load it up. This way I don't have to create a video. That's the last thing I want to do is have a single video file constantly being rewritten and rewritten. I just want to pass an image into a video buffer, which will then display an image. Let's see, getting started with no. Maybe we go with bits.io. Or bytes.io. Yeah, here we go. Use bytes.io object as a file path. Because this is how I remember doing this for MongoDB. So let's see here. I should be able to just, like with open, and then it should be the bits.io file. And then do something, and then it should be fine. It should work fine. So you could use pipe. Do you know any workaround? I have stored bit.io's objects, but I do not want IO or storage utilization. So how to pass a bits.io object directly to guest type function? All right. Kind of what we're wanting to do. And this looks like another rip-off of... This looks like another rip-off website. Actually, I wonder. I wonder. Yeah, I think... yeah, I don't think... yeah, I don't think this is going to work. Yeah, I don't think that's going to work. Hmm. Our PyQt6 test did not work. It crashed. Apparently, it took up too much memory and it just would not display properly. So we really need a video buffer. Oh, no, 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 not that, not that. Again, not a camera. I don't know why it wants to... Not a camera. No camera for... No camera for us. No, thank you. Hmm. OpenCV to Python Qt. Why is this such a... Oh, I even said no camera, and it's still showing examples with cameras. All right, I think Google is not... I don't think DuckDuckGo or Google is helping. Why don't we try a bot? So let's see if it will produce anything of use. Because I apparently I'm having difficulty finding any reference that could potentially help us with this. So what I'm going to do is I'm going to type in, let's see here, output a pillow image to OpenCV. So yeah, output a pillow image to OpenCV. The problem is how to prompt this. So in Python, output a pillow image file or pillow image instance to OpenCV video buffer for video capture. The video capture, let's see here. Output to OpenCV video buffer. The focus is for images to be uploaded to the buffer continuously to generate an animation. This will be displayed in a window for capture by a third-party software. All right, let's see. Does ChatGPT 4.0, does it work? Does it solve our health problems? To convert pillow images into a video buffer for continuous animation display, you can perform the following steps. Convert the image to a NumPy array. Write the frames to the video buffer. Continuously update the frames to display the old date. That's what I was trying to do. Yeah, that's what I was trying to do. Oh, and he gave us... All right. Let's try... Oh. To the testing grounds. So let's see here. Pillow to CSV. Generate animation. So this is what we want. Oh, CV2 can output its own window. Oh, I forgot about that. You're right. I don't need to use PyQt6 or tkinter. I can just use OpenCV. Let's see here. So what we do is we, for 1 into 100, we'll then do this, and then from here we can quit, and then here we can release the window. So here's our drawing here's our drawing. So where is this from? Image draw. Image draw is from Pillow. Okay. Wait a minute, wait a minute. What is going on here? Where is this function called in your example? It's right here. So we create a new image. We then draw on said image a rectangle. We then convert it to a frame. We then show it in CV2. Wait, I don't actually need to use the video capture buffer. Huh. I thought that's... Granted, when I was using it with the Raspberry Pi, I was using it to capture a camera, which is why I keep thinking of image capture. But I did use it for generating... This is why I wish I could go back to really old code. And this is why I wish my memory was a bit better and I can remember what I did 8 years ago. But if I could just do IMShow and print the frame, then that would solve a lot of the problems. So first things first, we're going to change this to a while loop. Oop. This is going to just be while true because I'm going to just have it continue running. We're not going to generate our own images right here. What we're going to do is we're going to load up our frame. So if you remember, I have BB right here, or actually it should be AA, correct? Yes, I have AA. Since it's in memory, we're just going to go with next AA, and this will be the frame. This will be framer. So we'll call this frame because this is a framer, and I just saw that turn blue. Is that a... Wait, is frame a special function name? Okay, maybe not. All right, anyway, frame. And then from here, we'll do frame dot show, like so. And then it'll save it into another frame. All right, let's try and run this. I can see it has a lot of garbage. Oh, it works. Oh, look at it. Oh, it works. It worked. Let me show you. It worked. Oh, check that out. I wonder what that is right there in the that dot. That shouldn't be there. All right, it's working. It's working. Now the major problem is that it's actually kind of slow. What is the frame? What's the What's the frames per second? Let's close. Oh yeah, I need to hit Q. Q. Let's see here. What's our button for escaping? Yeah, Q. Okay. All right, Q. There we go. Okay. All right, so that kind of worked. It looked like it was taking up a lot of resources, mind you. But if that's the case, let's see here. While true, we simply just... There is no limiting factor here. We're just setting up a normal animation window and then running it and then just updating it constantly. Yeah, it's just updating constantly. So if that's the case, we'll definitely have to pass this off to a different thread. We'll have to pass this off to a sub-process. And I don't know why it asked for time. It's not using it. But the main thing here is that IMShow is what we need. Is there a faster way to do IMShow, I wonder? Let's see here. We should measure... Let's see here. How to measure frames per second. So, let's see here. How to measure... Or let's see here. OpenCV. FPS. Is there a way to find the frames per second? There we go. This one. This is what we need. Timing. So we start time and then we simply perform our animation and then we do end time. Well, that's no. Let's see here. How about we do this? How about we do this? Why don't we time it ourselves? Let's go ahead and rerun this. There it is, right there, our animation. And okay, let's load this. Let's expand this a bit. Now the first thing I noticed is we're on a black background. Can this not deal? We need to see if we can convert it to with alpha channels. That's the first thing, because we are on I don't want it on a black background. That might explain why some. Actually, if you look, some of the image is being quite gargled. This is severely saturated because this is supposed to be alpha channeled, and they just noped it off. But for this, let's see here. That looks kind of about right, doesn't it? At least when it comes to talking. I mean, if you look at my character here, I currently have him running at 24 frames per second. And it works pretty... And the talking animation looks very much similar to what I'm doing. It'll probably be much faster on a different computer. I mean, this one we're using is really old. Doesn't have a lot of cores. But what we should see about doing is... Instead of converting it to this here, RGB to BGR. Is there a RGBA to BGRA? We should check. OpenCV RGBA. Space color conversions. Okay. Oh. Here we go. There's an A right there. That means alpha. So do they have RGBA? Here it is. RGBA to BGRA. I think they... Ooh, let's try that. It looks like it's a very simple change, too. We just have to change this here to an A and to an A. And... unknown file is loaded. Oh. It does not look like it worked. Yeah, it does not look like it worked. All right. But we're converting it to RGBA to RGB 2A. Let's see here. Let's go back over here. Oh, there's a lot of these. Here, adds alpha channel. Adds an alpha channel to these colors. Let's see, converts. We're looking for the A. Here it is, right here. So RGBA to BGR, RGBA to BGRA, right here. It actually doesn't, there's no actual quote here. This one says it'll add alpha channel to an image. This will remove an alpha channel. So yeah, this should be an alpha channel to alpha channel conversion that we're doing. Don't make me do it myself. I will do it myself if I have to. Oh, another thing we should check. When we're doing show, is it showing a Yeah, this right here. Once we do IM_show, is IM_show going to does it work with a alpha? That's also a question. OpenCV dot IM_show alpha. How to set transparency of a pixel. Here we go. The behavior you describe is to be expected. Apparently, this does not support transparency. This explains why your displayed image is all blue. IM_show doesn't support... Oh. Alright, so it doesn't support transparency. As for the saved image, it is important to remember that the image is of CV8, which means that each channel element... Oh, that's not going to work. So if so the problem is IM_show. IM_show doesn't support alpha channel. But then what does support alpha channel for outputting an image? Yeah, what does support an alpha channel? That's very alpha blending and masking, and no. I mean, if I have to, I'll just start using the green background again. I was kind of hoping that I could just pass alpha channel all the way through. That would save me a lot of headache. But if I have to start using the green background, I can. How to blend alpha transfer. So, let's see here. Why don't we try this? OpenCV video with alpha. Yeah, alpha channel and... Well, that's just merging. We're looking for... Yeah, here we go. This one. This one. Does it support it? I'm afraid this only works for webcams, not for video files using FFmpeg. So it's an FFmpeg problem. All right. Oh, All right. If that's the case, then we're going to have to just go with the green background. It seems, and this is a very recent... Okay, this is 2022, so this is quite recent. So yeah, okay. Green background it is. Green background it is. Let's go back to Framer. As much as I was having fun with RGB, we're going to have to... Let's see here. I currently set the default to be with alpha. Yeah, here it is, alpha. We're going to just get rid of the alpha. And because of that, our defaults... Well, our default will work just fine, but I think... Let's see here. Yeah, our defaults will work just fine. We'll set the background color. So let's see, where is background colors? Where do we set this exactly? We set it in two places. We set it on 42, which should be during the initialization. All right. And we set it during when we are just trying to run things. So with that being said, now when it comes to when we're calling our function, where are you being called? So here, now where are we being set? That's the bigger question. This is the iterator. Framer. I think it might be here. Oh, here we go. Yeah, right here. In this case, we're doing... let's see here. We're doing Framer, and we're selecting the stem name. That's giving us our name. And we should set it right here, the background color. Since we're using RGB, we're just going to do, let's see here, 0. This is 8-bit, so 255, 0. So that should give us our green background. let's go ahead and regenerate this now. Oh, DIR path. All right, DIR path. There we go. And then we'll set our sequencer. Oh, components. There we go. There we go. Nice. Now let's go ahead and get our sequence there. And now let's go back over here and run it in our test code, our testing ground. There we go. Hey, there we go. Perfect. Nice. It worked. We have our green background. Alpha is working fine. Now I bet if I try to filter this, it would work. Actually, you know what? Seeing as how we have, we're just piping the stream in, let me mess with the background. Let me mess with it. Let's see here. Mini. We'll filter. We'll add in a. See, that's the audio filter, effects filter, chroma key. There we go. And, oh, look at that. Oh, that is working nice. Check that out. We can see the background now. And it's actually it's actually moving a little bit faster since we're no longer messing with alphas. All right then. So yeah, that works. That's working quite well. Let's go ahead and get rid of the chroma key. All right. Okay, so yeah, this is how we're going to build our animator. What we'll do is we'll create a loop in OpenCV with ImShow, and then from that we through. Now, because we're going to need a variety of different key or tags, in other words, activators. What would you call it? Activators? Cues. We need a variety of cues in order to define what we want to do. For instance, peak audio will display the talking animation. Peak audio will display the talking animation. It's not talking, it will display the idle animation. So we need those, and we'll have to switch between them based off of what we can do. I think the first thing we'll do, that way we can at least get it working, and then once it's working, we'll then switch it over to collect or monitoring audio. I might have to create an audio generator though, because this computer doesn't have microphone input. At least the one that I'm programming on doesn't have microphone input. Actually, I wonder if I can tunnel it from this computer to there. I'll have to see if it will work. But for now, let's start. We have what we're going to do. Let's start transferring this over. So we're going to use CV2. We have to convert our files. And then from there, we can then do the animations. So let's start doing that. First things first, this file here. And seeing as how we have... Yeah, we ended up having a lot of... Let's see here. Yeah, we're not going to use tkinter. We're going to use the built-in. We're going to use the built-in functionality of OpenCV. That way, we won't have to deal with any. We won't have to deal with any widgets or any other things. Oh, and subprocessing. We will have to program that in. Or we can do asyncio. Let's just get the animation program built. Let's just get the animation code built into the animator first, and then we'll worry about asyncio. All right, we don't need the widgets anymore. There we go. Animation count. All right, then there's the default sequence. Okay, all right. So animation functions right here, and we don't need to worry about display window now. So first things first. This one. Oh. thinking about it, should this be part of Framer? I think I'm trying to think, because the animator, the whole purpose of the animator is to just run through the images. The whole output of an image, the whole output of an image is going to actually be in charge. All right, Framer is building the actual image, what will be displayed. Sequencer is streaming the images together to make an animation. We're making a whole bunch of iteratable lists. Animator is to take all of those lists of images and compile it into a file, into an application, where when we call talk or intro or the variety of different animations, it will then jump to said thing. So this pill to CV2 should not be here. This should be in the Framer. In fact, I think if I was going to be so bold, I would think that when we call show, let's see here, where is show? Here, when we call show, instead of just returning the composite image, we should actually run the conversion here. So we don't need this. All right then. So what we can do is we could take in a file. We probably should call it format. Actually, yeah, I think that's what we'll do. We'll call this CV2 format. And this will simply be a... What type is this? What is your type? What is your type? My type, it's an int. Why? It's an int. Wait a minute. It is an int. Okay. Integer. That means it, oh, I know how they did it. Okay. I know what they're doing. They most likely, because this is OpenCV, because it's all written in C++, most likely what they're doing is they have a switch. It was a what is it called? It is a... It's one of those switch functions where you call switch, is it called? I forget what it's called. But the main thing is that you give it a number and then it will go to said number within the list. It's much faster than for loops. It's much faster than for loops. And they're typically used when you have a long list of functions or a long list of actions you want to perform. But they're all case. Oh, there it is. Switch case. There it is. It's called switch case. So most likely the 5 is a switch case. Oh, that means we're going to have to put here a... There we go. So this is the CV2 color formats conversions. So yeah, I think that we'll do that. And in this case, we'll call this CV2 format. And the bigger thing is if this is none. So I actually want to make this none, and I want to make this callable, like so. So now what we can do here, so let's see here, we're already an RGB image, so we don't have to do that. Yeah, composite is already an RGB image. So yeah, we don't have to do that. Convert it to a NumPy array. So we do need to do that. So yeah, we'll convert this to a NumPy image. There we go. And then from here, we'll then convert it from here. And then last but not least, we will return our image file. But this is only on the impression if we have a format. If we don't have a format, then we're just going to return our file. So we'll send out, we'll call this output image. And this will be equal to self.composites. And then from here, we'll just simply, I should probably copy this. Because the last thing I want to do is mess with our file. So I'm going to make a copy of this, output this here. This is going to be an image file. And then we output that. And then finally, we just do this. There we go. And we should import in CV2. There we go. So if I call show with a CV2 format, then it will output a CV2 image. And with that in mind, when we're back here in the animator, instead of, let's see here. So this was the function right here. This is the function right here. So this is this right here, the animator. So let's go ahead and copy this. I'm going to convert this back to, let's go ahead and we'll put this as a default. So this is going to be the default CV2 format. And this is surprisingly is an int. There we go. RGB to BGR. Don't mind me. We're going to just make this a final so that the program knows what it's supposed to be. There we go. Oh, and I need to also import final. There we go. So now we have that. Next on the list is the animator. So originally we were going to call it video stream. That's how we were going to output our stuff. But for this case, they call it generate an animation. I guess we'll go with it for now. Yeah, I guess we'll go for it for now. We'll use generate animation. There we go. Now here we go. All right, so. All right. So far, so good. So now what we need to do is this. All right, so let's see here. Oh, there's a Ooh, there's a mosquito in here. It's trying to bite me. 1 second. I'm going to go. That mosquito has to go. Aha, I have my bug zapper with me. All right. I have my bug zapper with me. I don't see where he is though. All right, if I see him, he's going to have a shocking discovery. Yeah, mosquito problem in Hong Kong. There's tons of mosquitoes here. There's a ludicrous amount of mosquitoes here. Because of that, you can actually buy these little devices. They're like tennis rackets, but they have electricity going through them. And with it, you can pretty much, well, you can swipe them at mosquitoes and get them. And since they have holes through them, there's no wind pressure to help push the mosquito away. It makes it a very good device for neutralizing pests. But yeah, you have to find the mosquito first. And I don't see him. Anyway. So let's see here. We're going to create our window. Oh, this is a self. There we go. So first things first. And this is going to output none. All right, so first things first, we are going to create our window, and then while true, we are going to get our frame. If you look here, we have accessing our sequencer. We're going to get our frame, and then we're going to run it. So this is what we should do here is get frame. All right, so yeah, get frame. So self.get frame. We're going to use, right now we're just going to use the animation emotion happy because that's what we have set. And we're going to use the animation components, which is going to be the talking animation. So this should be our frame right here. And if anything, this should be an image file. There we go. Oh, all right, nice. And then from here, actually, is it an image file? When I do get frame, oh, I see. We haven't output anything yet. All right. Oh yeah, we haven't. We have our sequence get from. All right, back to here. Let's see here. Yeah. We don't want to do the dot show here. Yeah, we don't want to do dot show here now. We're going to do the next. We're going to output. Let's see here. Yeah, we're going to do next. This is not going to be an image. This is going to be a framer. Yeah, we're outputting ourselves. And then from here, when we say get frame, we have our framer. Let's see here. Yeah, this is it, the sequencer, get frame. We output the framer. And then from here, actually, you know, maybe we could put the form. Well, no, we'll set it right here for now, since the default is here. And this will give us our framer. And we'll call this frame. And then from here, we will return frame dot show. And this is where we'll put in our default CV format. And then from here, once we do that, that means we don't have to call this anymore. We just need to get our frame and then show it. Like so. Now let's see here. It's not going to be an image output anymore. It should be a NP array, I believe. And what's it complaining about here? Unexpected argument from show. But I thought we changed that. Yeah. Oh. Yeah, I forgot. I need to. Yes. I forgot. This should be CV2 format is equal to. There we go. All right, that should work actually. If we now, yeah, this should actually work. Let's run that. Oh yeah, we don't care about tkinter anymore. Be gone, tkinter. Where are you? Where are you, tkinter? Let's see here. Imp no mod. Yeah, I know there's no mod. Oh, it might be because of that one. There we go. Okay. Now let's load up animation. Let's see here. Self. Let's call this animator because we're using self right now for our sequencer. So animator equal or anime equals animator. Oh yeah, it needs to be capitalized. Oh, no, I know what I want. Don't autocorrect for me. There we go. And then anime dot generate animation. And we get an error. Okay. None type has an attribute get frame. None type. Nani. self.frame. This is the frequent. It's claiming it's this one right here. Oh, wait. Wait. We forgot to set. All right, we forgot to set the sequencer. Okay. Where's sequencer? Right here. Get sequencer. Yeah, we need to do that. All right. All right, get sequencer. If I remember, we called this, what, lemon tart? All right, now it should work. Let's try again. And, oh, but now what's this problem? Let's see here. Could not return this function. All right, sequencer get frame. It's all a problem. Okay, let's check it out. See, there's our sequencer. Oh. Why is animations empty? How much do you bet is... I bet I know. I bet I know. I bet I know. I bet I didn't pull lemon tart. I bet I pulled something else. Let's see here. That's animation frame. Oh, no, we want animator. Let's see here. Anime.get sequencer. Yeah, this one. Wait, we did name it properly. Wait a minute. Okay, where's my animation? It should have passed on through. Self dot animations. Oh, that's empty. Okay, why is that empty also? Did we forget to populate animations? Let's see. Oh, how much do you bet we did? I think we forgot to populate animations. Okay then. Self.add emotion. The add emote. Okay then. And we'll put in our animation emotions. This will be happy. And then we'll put in dir path. There we go. And then I guess we'll not worry about parameters. There we go. Okay, now let's go to anime. Not generate animation. And it's still complaining. Why though? It should be... Let's see here. And it... Wait a minute. What? Oh boy. This should be working, but this should be a singleton. So that means they should be connected. That's... Oh, I see. No, wait, I don't see. Yeah, they should be connected. I wonder why it's didn't work. All right. All right, we'll get the sequencer again for now. There we go. And just to be extra cautious, let's check see if the animations are in there, and they're not. Okay, what is going on here? What indeed is going on? Let's see here. Sequencer. Let's get not the sequences, but let's see here. What are our... Let's see here. What are our instances? Let's see here. We have lemon tart right here. That's one instance. And that's the only one. Okay, so... Okay, then so why is it not transferring the data over? That is very strange. Am I not... It should be... Let's see here. Get instance. That's the sequencer, animator. It should be working because... Yeah, it should be working. Yeah, get sequencer. Then we just get the instance and the name. Yeah, get instance with the name, and then we just load it in. So why is it not passing the data over? It's when we create a brand new function. Let's see here. When we create a new one, we create... How much you bet it's because it's not, this is the class variable. It's not actually associated with the instance. I bet that might be it. I bet that might be it. This is we set this to being a class variable. So what we want to do is let's see here. I'm going to set here, we want to set this inside our instance. I'm going to do this. That way it should activate our animation inside the instance, which is where it should be activated. This is a instance function, animations, not a... Yeah, this is an instance function, not a class function. Or variable. It's not an instance variable. It's a class, not a class variable. It's an instance variable. Okay, let's try and reload this again. So dir path. There we go. Self is going to equal our sequencer. We'll get an instance called lemon tart. And then from here, we will then add emote. And then from here, there we go. Then from here, we'll go to our animator. Actually, before we do that, self.animations. It is there. Okay, so we do see it. Now, if we proceed to create anime, we're going to grab, there we go, animator. Then anime.get or get sequencer, lemon tart. Now anime, sequencer, animations, and it's not there. Ah, why are you not there? I don't... All right then, why are you not there? All right then. It's an these are, let's see here. Let's see here. We are at sequencer.get instance lemon tart. This is definitely being very tart. This is what we're calling. So now BB should have an animations. But it is empty. But why? Why is it empty? When we go down here to add emote, we're adding to our animations file, which is right here. We're initializing. I bet it's written wrongly. I bet this is written wrongly. I thought it because originally I thought, you know, I will create a bunch of instances like so, and then from here I could have individual, you know, an individual or tracking the different instances, and then from there they can have their own different animations. So if I wanted to get, well, here we have lemon tart, but if I wanted to get pizza, then I would just like say get instance pizza, and then it'll get all of the animations for it. The reason why I was planning it this way is because of the fact that I have many different characters I would like to animate. I'm actually drawing an avatar for my wife. So whenever she decides to show up on stream, she will have her own little avatar that will bounce around and talk and do all sorts of things. And this is why I was trying to set it up to have multiple instances. But apparently, yeah, that's maybe instead of, oh, I have an idea. I have an idea. What I probably should do is change this so that instead of it being here, animations is here. Well, okay, I am trying to change it for the animations, but instead, I should probably put this everywhere. But that doesn't make any sense. It really doesn't. Yeah, this doesn't make any sense if I start just plastering this everywhere. Because if I did that, then it would probably throw an error. Yeah, it doesn't like... the name should be the instance that I pulled from. And the idea... Alright then. If I set it... Because if I set the animation here, if I set this to, just initialize it right here immediately, then what happens is this will be shared everywhere. And I don't want it to be shared everywhere. I want it to be... Yeah, I don't want this to be shared everywhere. What I would like is for this to be instance specific. So to do that, you simply set it to none, and then you initialize it when you create said instance, which is what I was trying to do. And to do that, you would simply... It would be in the new statement. Whenever you call underscore initialize, I should say. And when it's in the initialization statement, when you do underscore initialize, it will then run it. But because we're creating a singleton and we're using new, we can't exactly do an initialization. So most likely, we'll have to do it somewhere else. So yeah, right here we have an instance. Oh, I have an idea. Let's see here. What we'll do is this. Well, actually, maybe not here. Let's see here. I want to... Oh boy. I'm trying to think what to do. Because you type in instance and you can see all of the instances that are available. I think I might see what part of the problem is. I'm not outputting the actual instance. I'm not returning the actual instance. I'm returning the entire object. That could be, yeah, that could be a problem. All right, maybe that might be the problem. Let's recreate this. Let's recreate this. And sequencer lemon tart, dir path. No, not parth, path. Self.add emote, and we're going to simply add in our happy path. Oh, nope. Oh yeah, we still need to initialize this. Yeah, we still need to initialize this. I forgot. We're going to put that back. Instance, name, and then dot animations equal that. There we go. Okay. Actually, I don't think we need the dot. No, we need a dot. Okay. All right. Okay. One more time. Fingers and toes crossed. All right. All right, then add emote, And there we go. All right then. Now, time for the... Okay then. Now then, time for the ultimate test. We go to Animator. And we call for this self... Oh, sorry, not self. Anime equal... Oops. Anime equals this. Anime get sequencer lemon tarts. Anime sequencer animations. And it's still not there. It's still not there. And the animations are there. What happens if I do self.instance? And it says, see, we can see lemon tarts. Let's see here. I'm going to type get lemon tart. There's our sequencer. Now I'm going to, let's see here. We'll just call this AA for now. AA dot animations. And, that might be how we have to do it. Because I see the animations now. So where is our get instance function? Get instance. So if this doesn't, but that's what I'm doing. But that's kind of what I'm doing. We have our instance, get name, and then this is what we're returning right here. Let's see here. If name is not in the instances, then we create a new one. But that's, yeah, that, so we're not running that. Okay, let me do this. AA or BB equals sequencer dot get instance lemon tart BB dot animations, and it's empty. So what is the difference here? Oh, I think I might know. I think I might know what the difference is. I think the difference is the fact that this is a class function, and then this is a this is actually kind of an instance function. So, but this has to be a class function because this is exactly what this is. It's a class. But I'm not really, but yeah, it's a class function. So when I type in sequencer dot instance, it should come up, instance. Wait. I think I might be beginning to see a problem here. Yeah, I think I might be beginning to see a problem here. It might be because I set it as a property. I bet if I look at sequencer underscore instance, yeah, there it is, lemon tarts. Get lemon tart. Not animations. Yeah, so, very peculiar, very peculiar. I think there might be some, I'm gonna get rid of the instance. Yeah, I'm gonna get rid of the property. There we go, and all right, let's try this. We'll go ahead and just turn this back to a normal, oh, whoopsie, nope. Don't do that, don't do that. We're just going to turn this back to a normal, we're not going to protect it anymore. Just call it a normal instance. And see, maybe it's the fact that I was setting it as a property that it's having difficulty. Self dot, let's see here. Self dot sequencer, and we'll get the instance. We want lemon tart. So if we have self that exists, self.animations is currently set. All right then, dir path self.add emote. There we go. Now let's go to sequencer.get instance lemon tart AA. Now AA, we should be able to see the animations, and there it is. Okay then. I think it might be because I set it as a property. Because I was trying to protect it. And as such, it must have started messing up because now it's working. That's right there, it's working. And I bet if I type in now, let's type in sequencer. Let's try it. Let's do a different one. BB sequencer dot get instance. And now we're going to call this, we'll call this apple cake. So now if we do BB, we have the sequencer. But now if we do sequencer and we check out our, just look at the instance, we have both of them. And the final test, if we do BB animations, is nothing. But if we do self animations, we have the, there we go. Okay. All right then. I think we've solved that. So let's see here. That means so for the sequencer, that is correct. So for animator, that means theoretically we didn't have to change anything in animator. We're still collecting the frames the way we would. So now if we run this, we'll go with animator self.get. Let's see here. Not get generate map. No. We want to get the. Oh, sorry. Anime.get sequencer lemon tarts. Now, anime.generate animation. And it's very close. Ooh, it's very close. What happened? Our frame showed up right here. Let's see, our frame showed up. But it showed up and it crashed. Let's see here. What's the problem? Next. Could not. It involves the key error. All right then. Let's see here. Emotes. Oh, we probably should store CV2 in the window. We should probably store this in its own variable name. Because as it is right now, I can't actually destroy this. I can force it to quit. And it will crash the system, but yeah, I think what we'll have to do is we'll have to set this so that I can then destroy the window when we want to. Well, that does say destroy a window, so it shouldn't be too much of a problem. But the main point is down here. So let's get this. Let's get this set up. Let's see here. There we go. And then for the animator. And then get sequencer. There we go. Okay, that is all set. Now, if we recall, it was saying that it was having trouble getting the frame, which means it's this right here. So the emote, the component. So let's try this. So emote is happy. There we go. The component is idle. Reset loop is false. So let's see here. What happens if we run this? Oh. If we run this, if we can also get rid of all the extra fluff, because apparently need to type it. There we go. We receive a Reset loop is not defined. Let's see here. Kier, reset loop. Did you mean reset? Oh, please don't tell me I wrote it wrong. Is it reset lop? No, it's reset loop. Error name. Reset loop is not defined. Did you mean reset lop? How much do you bet is the running in the background? Let's see here. Animator. This is reset loop, get frame, get animation, or generate animation, which would be this one. Okay, where is reset lop? Did you mean reset lop? Where is that? Yeah, where is reset lop? Reset loop. Okay, let's go to get frame. Get frame has reset loop right here, but is not being used, so it doesn't matter. All we're doing is we're running through the animations to collect the components. That's what get frame does. And animations doesn't have, animations is just a dictionary. Let's see here, run error code. I'm going to get rid of this for now. Well, actually, if I do, then it will throw in, we'll have to reset everything. But technically, what I did should not have a problem. Oh. How much you bet that's where the error is? I actually called that lop. Yeah, there we go. Okay. Yeah, the file is called lop. Okay. All right. Could not access this file. Okay then. Anime.sequencer.animations. We have... It is empty. Why is it empty? Okay. Am I still messing something up here? It would... We got rid of the... that issue. Animator. Up here. Where are you? Sequencer. Get instance name. I'm running it exactly as it should be. I'm running it exactly as it should be. Why is it... Okay, sequencer dot instances instance. We have lemon tart. Get lemon tart. All right then, animations. Why is this? Why? Let's see here, get instance. It should be just instance, get the name. We already established the instance that it exists. I don't know what is wrong. I really don't. I really do not understand what the problem is. Let's see here. If this continues going this way, what I'm going to have to probably do is actually start digging deeper into how instances are controlled in Python to understand why is it not working. Because this is so far, it's making no sense at all. Let's see here. Self is a sequence. in sequencer, we have sequencer in our instances. We have the same thing. Are the codes the same? No, they're not. Why are the memory codes different? Wait, why are the memory codes different? We should be okay, then why are the memory codes different? I am now super curious. Why is that? Because if you look here, self is at this memory address. And then if you look at our instance within our sequencer, it is at this memory address. They are very different. They're not the same. So the question is why is it that the self has a why does it have a different memory address? I'm getting the instance. You can see here, I'm getting the instance. We're creating it. We're creating it. We're storing it in our instance class. We're then adding in animations, and then we are returning it. That is the new function. And when we do get instance, what we do is we check to see if it exists, as in does the name exist in the keys. If it does exist, then don't do anything. If it doesn't, then create it, which would automatically put it into instances, and then we call instance to return it. So why? Maybe if I change this to get name, that doesn't make any sense. All this is doing is making sure that the code is the same. Though that being said, I am doing get instance multiple times. Maybe I should just be returning the instance. But again, that doesn't. But that wouldn't. But we want our actual instance to be returned. Okay. How? Okay then. Think this through. So, think this through. We call new. It creates a new file. We then store new file in the instance folder, and then we return it. So when I call get instance, we're checking to see if the file exists. If it exists, then we're just going to call instance and get it. So technically, this return function is not, we're not doing anything with this return function. If I deleted this, nothing would happen. Though, because this is a special character, that means technically, if I called new, let's see here, if I call instance and say get, it should, All right. I know what I'm going to do. If you remember, we programmed this a while ago. We found the thing about multiple instances. So let's check that out. Let's go with Python singleton new, like that. I believe we found the best practices book. Yeah, Python developers singleton. And in here, it should have told us. Oh, okay, maybe not here. All right, where are you? There was a coding practices book. There was a coding practices book that design patterns. Oh wait, we were just here. But I don't remember I don't remember it looking like that. I really don't. Let's see here. Where is it? It really wants to show me the design pattern. Oh yeah, software patterns. Is that it? Oh, is this it? Oh, I think it's this one. Yeah. Yep, this is this one. This is this one. So let's see here. Singleton as a module, singleton as a class registry, database. This is the lazy initialization, which is kind of this is a single instance iteration here, where we simply call the the class as none, and then well, actually that's a bit different from what I was doing. Where's the new function? Here this is as a decorator. This is the basic one. Double threading, no. Singleton with Borg design. No. Singleton as a module. No. Class registry. Yeah, this is kind of what we were doing here. Yeah, this is kind of what we're doing right here. You can see here, we register an instance and then we get it. But I was trying to combine this together because the idea would be is you just give it the name, and then if it doesn't exist, then we just create it. So as you can see here, yeah, right here, I was trying to make this a class variable. So the idea is that we create this file as an instance, and we then import it in as name. This is very similar to the registration, except you don't have to call register. And then when you want to, you can just get the instance that you are looking for. This way, you just type in get instance, you just classify what you want, and then it will automatically generate it for you if you don't have a, or if it's not there. And then also, because it's set as a class method, that means then it should forever exist, so that I don't have to, I don't have to do this registry stuff. Well, technically, if you look here, these are class methods, so you can do, it's still singleton, it's still a class method. But apparently the automation step that I'm doing right here with a new function is not working. It's definitely putting them in different memory locations, which I don't understand why. Is that one of them potentially create... Oh, actually, is one of them potentially... Is it one of them causing a copy function? That might potentially be one of the problems, is that I'm copying somewhere. If I call this should create a new instance. And if the name isn't in the list, then we would create a new instance. Otherwise, we would just get the file. I wonder. Instead of get function, I'm going to change this to... Again, I highly doubt this is matters, but I'm going to change it to this. Yeah, I kind of thought so. Yeah, I kind of thought so, because that's just a different way of calling a function. The main point is that these are in different areas in the memory. I was kind of hoping that I'd be getting around a copy function. I might have to just set up a registration setup. Instead of just doing this new parameter thing, I might just have to go, oh, we want this, we just register it, because apparently this is not working. Let's see here. There should be maybe one other area. No, not you. Where is the other Python morsels? I don't think so. No, it's not this one. Though it does provide some of the code that we've seen before. For instance, this is what I'm doing. Maybe they might dive a bit deeper in. Singletons, import, no. Yeah, that was worthless. Oh, that was worthless. Oh yeah, super worthless. singleton, we'll type in underscore new. Hopefully that will pulls out what we were looking at earlier. Stack abuse. All right, stack abuse. What about you? Oh, that's just a rip off of that one question. That's not it. That's not it. I wish I knew where that went. I really do. I wish I knew where that went because I don't see it anywhere. I think it was this one and I was just trying to be smart. Yeah, I think I was just me trying to be smart, combining a decorator inside the actual function. So if class is not in instances, then instances class, we import the argument, and then we return instances.class. And then we get the instance. And then this will be kind of what we were doing. We do, instead though, we classify it instance, we sort, yeah, because I didn't want to make it a decorator. All right. Yeah, we're going to register it. We're changing this. If it's going to have a lot of trouble, we're just going to do the registration setup. Yeah, here we go, as a registry. So instead, we'll call this, we'll change this here to registry. There we go. We're no longer going to create a new function. There we go. Instead, we're going to just simply do this, which is a register. It's an extra step, but it's an extra step, but it's a step that we have to take. No, that's all we can do. So here we go. So now we have that. The next thing is to see here when we do a get instance, and then we just simply return return it. Now, why does it feel like that I'm doing something a bit differently? Which means we're going to have to create the instance, and then we're going to have to register said instance. I wonder, I have an idea. So I'm going to call this instance, and we'll do CLS dot, we'll do CLS this. We'll put name. That should create our instance right here. Oh, I'm going to go ahead and get rid of that. And because of this, we're also changing the initial. We are going to also, we're not using new anymore, so we can define an initialization. That way we can define new instances. And in this particular case, we're taking in our name. Name, string, there we go. Actually, we don't need the name. We don't need, thinking about it, we actually don't need those right now. We'll worry about those in a sec. Well, actually, no, we won't. We'll put that here. And what we'll do is we will initialize our animations. There we go. So we're now initialized. The name will come later. So the first thing is if it's not in our registry, then we'll create an instance. We will then store said instance in the registry. Oh, and this will be a class. We will store the said instance, so this will be name, and then we'll put the instance in there, like so. We don't need our quargs and args anymore. And then from here, we'll then return our instance. So there we go. Kind of a slight variation. As long as we call get instance, it should be fine. If we call sequencer by itself, it will not be registered. The whole point of doing the new function was to always, to constantly register it. But if we can't do that, then we'll do this. Let's go ahead and reload this. All right, dir path. Oh, why does it sound like the music stopped? Oh, I think... Let me reset that. There we go. So there we go. Now let's go with... let's go with self. Dot sequencer get instance lemon tart. There we go. Now then, what is self? Self happens to be at memory address 7583. So what about if we look at sequencer? Dot registry. We have lemon tart, and it is at the same memory location. All right then. So that means let's go ahead and do add animation. There we go. Now our animator. Self, or anime. Animator, self, or I want to put in self. Anime dot get sequencer lemon tart. Anime dot sequencer, and the memory address is 90. Let's see here. 758E. And if I remember, it was 758E earlier, wasn't it? Let's head on up. And 7580. Yes, yes. This is the same memory address. Okay, then. If that's the case, then if we do anime.sequencer.animations, it is not there. Okay, then. Self.animations. Why is it not there? They're the same memory address. Registry. All right, then dot get lemon tart dot animations. Oh, what is going on? Why? We registered it. We registered it. Why is it not working? It has been registered. We registered it. Right here, instance. We created our instance with our own class. We returned said instance. It has the exact same everything. It's not a copy. It shouldn't be a copy. In fact, it has this, as I said, it has the same memory address. Let's see here. So let's see here. Self has that memory address. Actually, self is equal to, let's see here. We have here sequencer, this one, lemon tart. Is it equal to self? False. Why is it false? Why are they not the same? And I bet it's not even the same as an is. Yeah, they're false. Why is it not the same? We're even doing the same thing. Gets right here. Exact same thing. Self, get a registry, get name. This is a singleton with a class registry. So let's see here. Class, registry, name, instance. And this is simply the register. In fact, I'm not even calling register. I'm calling the class function. Uh, oh, hmm. This is very strange. They're not the same. Sequencer.register. Oh, first things first. Let's do this. Let's go with, let's call this KB is equal to sequencer, this thing. So KB. So here's our animation sequencer. Now let's do KB. Is it because it's still in itself? Do I have to actually create a completely separate function called a registry or register, sequence register, and then use that? But again, it's a class function. It should just be purely within the class. Because now I can do sequencer.register, and we'll call this pi, and then we'll call this KB. There we go. Now when I type in sequencer.registry, we now have pi and lemon tart. So now when I do, let's see here. Yeah, so now that I do this, I should be able to simply get the instance. I'm just going to go cut straight into here. I'm going to go grab pi, and instead we'll call this BB. So here's BB, same memory instance. Is BB equal to KB? Yes. So that is correct. Could it be because we're doing it all in the same function? Is it possible that the reason why it's having a failure is because is it because of this? I wonder, is it because of that? It's very difficult to say. We're creating an instance called instance. We're then registering said instance. I don't know why this would be a problem. Especially seeing as how we just register. All right, well, if this is going to be how it is, then I think what we'll have to do is over here in the animate, or the whole point is to build these things by ourselves in a different area. All right, well, all right, let's try it the way it wants to try it. Self equals sequencer lemon tart. Oh, actually, not get instance, just this. There's our sequencer. Then we'll go with sequencer.register. And then from here, it will be lemon tart self. Now that we have that, we've registered it, let's go ahead and import in all our data. There we go. Now that we have this, if we do self, okay, let's go to sequencer dot get instance. Oh, not that one. Get instance lemon tart. Is this self? True. Okay, then so they claim they're the same. So now that we know that they should theoretically be the same, let's set animator self dot get actually this should be get anime get sequencer, and this will be lemon tart, anime sequencer dot animations, and none type. Self dot animations and wow. What? 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 What is... Why is this not working? Sequencer, get instance, and name. We're just to be able to just get the lemon tart. Why won't it get the lemon tart? We're not even changing sequencer. We're just importing in sequencer. So it should be registered. Everything should be registered with sequencer. Let's see here. Sequencer, this lowercase sequencer. So it's not capitalized, so that shouldn't have an impact. Sequencer, get instance, and then we want the lemon tart. In fact, let's see here. Sequencer dot get instance lemon tart dot animations, and something is messing up here. Something is not making sense because we registered this sequence. Let's see here. And they're false now. Something is going on here. The question is what is going on here? Because now they're false. When we checked earlier, they were true. Let's see here. Is it because I called get sequencer again? But that shouldn't work because it's already been called in. Yeah, if you look here, they're now not the same. This is very weird. This is very strange. I want to try something. Real quick. Let's see here. Sequencer. And then we're going to just simply register it as... Oh, no. Sequencer. Not get... Let's see here. We want the Oh, where is register? There it is, register. There we go. And then self dot add emote. There we go. Oh yeah. dir path. The add emote. There we go. Now let's see here. We want to get our instance there, and it's true. All right. So we know it is true. I am going to go over to Animator. I am going to block out this. And I'm going to block these out. Now let's run this. Anime is equal to Animator. There we go. Now self is equal to anime dot get sequencer. Oh. Anime dot get sequencer. Come on. There we go. Lemon tart. That is still true. Self dot. All right. So anime dot sequencer dot animations. Why is calling it again causing it to crash? Apparently, when I call this here import sequencer, it goes bananas and it creates a new instance and it formats everything. So, oh wait, does this mean that my previous setup was fine? I'm going to try that. I'm going back. Let's go back there and try that. Let's see here. I'm gonna do that. Where is our changes? Right here, sequencer. Let's see here. Here it is. Here's the old stuff that we were doing right here. We're not going to worry about property right now. We'll just go ahead and grab this, the singleton code. Well, actually, we did worry about the initial. We'll initialize it here, like we had been doing. Dot animations, and there we go. We'll initialize it here. And the last thing we'll do is we'll simply change all of these to registry. That way we don't have to fumble about with renaming. There. So this was the original way that we did it. Let's rerun this. There. self.sequencer.getInstance. And we're going to call this something else. Lemon tart is too long. We're going to call this Choco. All right then. So sequencer.getInstance. No, this is going to be Choco. Choco. That is true. All right. So that worked. So now that we have that, let's do a dir path is equal to, not path is equal to that. Self.add emote there. Now let's go back and check again. It's still true. Now then, let's go to animator. We're going to block this out. And we'll block framer out too. There. Self dot, or not self, anime. Dot, oh, no. Anime equal, okay. Anime equal, anime equals anime dot get sequencer Choco. Now then, anime sequencer dot animations. Wow, it was working. Okay then. So I'm not crazy. I am not crazy. The way I was programming it does work. So why is it now that whenever I call this, it goes bananas and it tries to create a brand new instance? This doesn't make any sense. It really doesn't. The sequencer, because we want to call in our instance. This is why I'm getting it from there. But apparently it's not getting it from there. It's just creating a brand new one. And every time I do this, it just craps out. So is this... Okay. All right. One moment. You didn't... Oh, okay. Okay. We're going to go over to the terminal. And I remember doing this. You could easily find out what the version was just by doing that. Well, that might just be for the modules. Okay then. if I recall, Python, the one I'm using is the one of the later ones. So it should be like Python 13 or Python 10. Is this like a glitch or something? Is this like a glitch, or is there just something we should probably... I probably should put this on Stack Overflow to find out, because watch this, watch this. Let's see here. So anime dot sequencer dot is self. They're the same. Now then, we know this. Now then, if I import this in, they should be the same. True, it is the same. Okay then. So, okay then. It's the, but wait. It might be because I didn't set it. Let's do that. Let's do that. Let's do this. Anime.get sequencer, and this will be Choco. Now then, is this the same? No. Okay, yes, that is the problem. The problem is here. It is when I call animation sequencer, import sequencer, it's not actually getting the instance. It is creating something new. Now the question is why? Because if you look here, when this is a class function, whenever you call this class, it should be working everywhere. There shouldn't be this different instances situation going on. When I used this in Python 3.8, it did not have this problem. So why is it having this problem now? I do not know. It is very, very infuriating. I wonder, Let's start looking this up. Let's see here. So Python import module singleton. Using a module as a singleton. Let's see here. No. Technically, Python modules are singletons. So from this point of view, there's no particular issue, except the usual issues with singletons. That is, with your code, I'd like to spell the variable of all lower caps, or the prefix is, it will either be a single protected or a double really private. Led underscore to make it clear. Whether the singletons are a good idea is another debate, but it's not the point here. Wait, is there a debate about singletons? But what's wrong with using something with shared memory? I know that a singleton is a very bad idea if you're trying to, because you run the risk of memory leakage, as in one module will leak its memory into another one. So not having singletons will make it easier to keep things independent. But what I'm trying to do here with my animation is I want to actually tie them together, because the general idea is that the animator will be working independent from like the frame generator, and the frame generator will be using a GUI or something to create the images. And then this way I could have one currently running and then the other one making new frames, and then they would just share the sequencer singleton, which would then pass the data over. It's a one directional, so the animator won't be able to modify the builder, but the builder will be able to generate new items, and then the animator should have access to it. The general idea would be that general idea as you could think of it is, let me load up GIMP so I can explain it. So here's GIMP. Let's load up a new file. There we go. And let's change this to white so that it won't, so we can see. So the idea is as follows. We have ourselves, whoops. So we have ourselves, oh, that's a bit large. So we have ourselves the sequencer, which is right here. And then from here, it can generate, it can generate happy animations, it can have sad, it can have angry. And the idea would be that from here, while this is doing this, the animator is over here just kind of doing its own thing. It's just looping through our series of frames, and it's just constantly doing this loop. And whenever we say, change from happy to, change to happy to sad, it will then switch to another sequence and then just start going through that one. So the idea is that we have multiple sequences and it will switch between them based off of that. And the idea would be that, as I said, this is a one-directional. So when the sequencer goes, oh, we have a new thing, something brand new. This is called agitated. Then suddenly, the animator will have a new sequence called agitated that it can start swapping between. And this way, I don't have to load it into Animator. As long as the sequencer builds it and has it, the animator will have it. To have to switch between them, I can figure that out later. But the main point is that when this generates something, this can access it and use it. And this is why I'm using a singleton. Is so that this will work. But for some strange reason, that's not happening. When I call this from source animation sequencer import sequencer, it's not doing it. Maybe because it's called sequencer right here, that it's causing an error. Since I have sequencer here and then there's sequencer here, but that doesn't make sense. That shouldn't. It's literally, as soon as I ran this, they became false, as in they no longer were the same. That doesn't make sense. I'm going to have to throw this onto Stack Overflow. I might have to throw this in, because this is what theoretically should work, and it works wonders when I'm not importing these in. It's definitely not working when I do. And I figured the get instance would be it. I could just simply call get instance, it'll pull the instance, and it'll be fine, but let's see here. Oh, I know. We have Poe loaded, don't we? Yeah, we have Poe. Let's see here. Let's see if the chatbot can figure it out. Before we go talk to Stack Overflow, let's see here. Okay then. Not a singleton when running from we'll call it src.data file imports my class. Not singleton. Why does this happen? Let's see here. When you encounter a situation this is not acting as a singleton when imported from here, this is likely due to Python handle imports. Specifically, the issue arises because the module may be imported multiple times or in different ways, leading to multiple instances. But that's the point. It's a singleton. It shouldn't have multiple instances. Let's see how different import paths. Let's see here. Import system keeps the file loaded in modules if the import file is the same. I wonder if this is accurate. Python treats them as different modules because the import paths are not identical. As a result, my class definition in src file may exist in separate namespaces, causing multiple instances. All right, so from this import class and then import this. And they're both false. All right. Circular imports. If there is a circular dependency in your code, file A imports B and B imports A, Python may partially load modules and create new instances during each import. This can lead to classes being redefined or initialized multiple times, breaking the singleton behavior. Well, this is one way. The animator is only importing in singleton. It's not the other way around, so that's not it. And it has nothing to do with Flask. Always use the same import path, but that's not what we're doing here. Use the singleton design pattern. That is exactly what we're doing here. That is exactly what we're doing here. In fact, we even have it right here. Look at that. In our sequencer, we have new. Right here, new. And we're registering it. Granted, we're not registering. We should probably do this. We probably should put here return this. Maybe. But we were getting back it being correct anyway. Yeah, we're getting it correct anyway, even though when we were doing this. And when we were, and it's also it affected it when we were registering. That's also a key thing. When we registered, it threw an error, which doesn't make sense, because registering it with the singleton should not have an error when we call that singleton in. All right then, self. There we go. And then we'll do self dot dir path is equal to that self dot load emote. Add emote. Add emote. There we go. Now let's go to sequencer dot get instance. Let's see here. Are these the same? Yes, they are the same. They are still the same. All right then. Now I'm going to go up here, over here to animator. We will now import sequencer. Now the question is, are they still the same? No, they're not. But it's not where, but that should not be. That should. Let's see here. We're calling sequencer immediately from here. We're building the class here. We're building the class here. Maybe that might be the problem. That might be the problem. Let's try a test. Let's go back to testing grounds. Let's see here. We're done with you. So let's go ahead and go to animator. We'll import this in. All right, so there we go. And then from here, we'll do sequencer.getInstance. We'll go with Choco. And then, and we'll call this, since we're going to type it here, we'll call this seek. Then seek will be add emote. Let's go ahead and grab our dir path. Here it is. This is our dir path. Then we'll go ahead and grab this part here where we add our emote. There we go. Next is this one right here. We'll add the path in. We'll add the emotion in here. There we go. How much do you bet this might be the problem? All right then. Restart. Run. Animator. Run. Self is equal to animator. Self.get sequencer, and this will be Choco. Now then, self.sequencer.animations. Oh, that's the problem. Oh, that's the problem. Okay then. All right then. We're going to, because this, all right then. It's because I was doing everything. It's, oh, I accidentally left that up. Stop. So, okay, I ran it. It worked. Look here. You can see it's, if you look here, I ended up creating in the test ground. Here we go. Import path, sequencer, animation. And then here we import in our data. We create the sequence that we want to make. If you notice, the import path is the same as the import path here is the same as in Animator. Is identical. Because of that, whenever we call this, it will keep it as the same instance. So now that I do that, whenever I call, see here, you can see sequencer animations, it actually worked. So now if I do this, if I do self.generate animation, there's our animation. It works. So that was the problem. So there you go. It's working now. So yeah. Oh, I need to quit that. All right, there we go. So if we go back over to Python, or over to here, the main problem is this. Constant import, ensuring the consistent import paths. Apparently, if the paths are different, as in you're not calling from the same path, as they show here, it will make them out to be false. This is apparently accurate. From at least ChatGPT made this accurate explanation. That is a bit surprising, actually. So, yeah, that's a bit surprising, actually, because I don't recall this being the same. I don't recall this being the same when I was doing it when I programmed in other languages. Or maybe it might just be that I never ran into this problem. But it's good to know. But that does mean one major thing. We're building the sequencer here. You know, we're building all of the functions and such here. But we're going to have to, let's see here. Yeah, we're building the function here. But what we're going to have to do is we're going to actually have to build a separate function. So we have test ground. So let's go ahead and actually do that. Let's go ahead and add that in. So these are the animation components. We have our animator, framer, sequencer, but then we probably should create a new here. So we'll create a new directory and we'll call this builders. We'll call this builder. And in here, this file, we'll call this sequence builder. And we'll track this, and in sequence builder, we will start here like this. And then likewise, we'll have a class. We'll call this sequence builder. And then from here, we'll also have our sequencer. And then we'll define our initialization. And then from here, we will self.sequencer.getInst and this equals sequencer.getInstance. And in this case, we will have to have a global name. So right now, we'll set this to name here. There we go. So if we want to do any building, we have to do it here. But that pretty much means that a lot of our functions, that a lot of the stuff that we're creating in our sequencer here, yeah, all of this stuff we'll have to be keeping track of. If anything, because of the fact that it can no longer hold a sequence, we might want to parse this. We might want to parse this out. Make this singleton purely focus on building the sequences and have a different function or a different class hold the sequences. Because right now, animations is kept within the instance, or kept within here. And what we would really be doing is for our overlay function or class, our wrapper class, I should say, our wrapper class, it will just be calling these with the extensions and then just, running it. That wouldn't be a problem, mind you. That would work fine. We could do it that way. A bit annoying though. But all right, we've figured it out. We spent way too long solving a problem that seemed to, we spent way too long solving a problem that apparently is not really a problem. It's just that not enough Python experience, I guess. Not enough singleton experience. But there we go. We now have it set. We now have them connected. We see that they're, testing ground is fine. We don't need that now. We have our sequencer. We have our builder, which we will use. In fact, we should probably, we'll have to deal with this right here. So, to do is write builder for generating animations. Okay, there we go. Technically we do have to do this because if you remember, I was saying I want to build a builder. Well, apparently with the instances that we're doing, we're going to have to. But all right, so that's working. This is working. The next step is to introduce warp. Let's see here. How long I've been for? Oh man, we spent an hour trying to figure out that one problem. Oh my, that is nuts. Oh, that is nuts. But now I know. Now I know. And isn't there like a famous G.I. Joe who goes, and knowing is half the battle? Well, yeah, now that I know, I will not make the same mistake twice. Until I forget it, which seems to happen a lot. So let's see here. Now that we're here, we have these kind of things set up. We should probably start importing in the ability to swap between the different animations. Let's see here. What I'm more interested in right now is warp. I actually do want to warp the image a bit. If you notice here, what's going on with the function is instead of calling show, we call warp. They both kind of do the same thing, as in, well, they both used to do the same thing. Now that I see that they're not, we're going to have to fix that. But the idea was that we would collect our image, and then we would proceed to modify it. So in order to do this, we're going to do something similar. We already have our output image. Let's update warp so that we don't mess something up. Technically, it's going to be a copy paste like this. And we're going to have we're going to import this as well. There we go. And then last but not least, we'll simply warp the image. And we'll call it outputs, or actually, yeah, we'll call it outputs. We will do that. And then we will simply put that there. And then we'll return our output image. And there's a much easier way to write this. Oh, there's a much easier way to write this. Because of the fact that this is almost, the only difference really is this function right here. If I wanted to, I could simply put warp in the show right here and then call it a day. Another way to potentially do it is to another potential way to do it is to simply crop out like this part here and put it in its own function. Or in fact, even then, move warp to a different location. I think we'll keep it like this for now. Technically, when we come to, yeah, the warp is supposed to automatically modify the frame. Because the idea was that it's, on-the-fly modifications. And if we look at sequencer, we go down. Where are you, good sequencer, my friend? So here's load sequence. We have different parameters here to modify them. There's the directory. Get frame right here. So in this case, we're just going to get, to the animator. And in this case, we call show. Oh, this looks like it looks like we're going to have to do a complete rewrite a little bit, because I don't want to, the idea is that the sequencer is going, yeah, we're going to have to change this. We really are. Because the whole idea is that the sequencer is going to keep track of the animations. This is literally just to print it. So that means for sequencer, when we call show, it should be the one to make the decision about how the picture is going to be presented. So this is all back in the sequencer here. So that means warp has to be put in here somewhere. If I recall, framer, where is this being used? This is being used in, that's being used in get frame in the animator. But what about warp? Where's warp being used? Warp is not being used anywhere. What about underscore warp? That is being used in 2 locations. These 2 locations happen to be when we run compile to generate composite. All right, and where's the other time that we run this? Up here, right here in warp. Okay then. So when do we run compile? When I run show, we go to composite and get a copy. When I do composite, I always say, I do while composite is none, we will run compile. And that's the only time I run compile. So once I compile it, we can't compile it anymore. That is probably not wise. We probably want to be able to call compile whenever we want. So we should probably put refresh here. This is a Boolean. And we're going to set this to false. Now the idea is that if it's refresh or composite is none, then we will compile it and then we will produce then we'll return our composite. That's the idea. So that now whenever we run refresh on composite, it will do that. Now that we've done that, wherever we run compile, let's see here. So let's see here. Now if we run compile, all the way down here. So here's composite copy, and then here is another copy. And then here's another one. So pretty much these are all of the copyings here. So if that's the case, what we need to do then is set this. We should probably set a refresh right here. Refresh. And we'll set refresh here too. Refresh, it's a Boolean, and this is set to false for now. We set it to false for now. So if we do this, oh. Yes. Oh, add to docstring. Okay, there we go. Refresh. And this will pretty much be recompile the image. There we go. So now let's go ahead and add these here as well. We'll add this to here. Actually, because of the fact that warp here, because of the fact that we're kind of warping it during the compilation phase, we might not have to warp it here. The whole idea of warp here was to do it after all of, because warping at the top is all about the layers. If you look here in compile, we're going layer by layer by layer. And then based off of that, we're going to, warp it we're going to warp each layer. So if we don't want to do that, if we just want to warp the final output, that was kind of the idea of the warp right here. Oh, all the way down. Yeah, that's kind of the idea of warp right here, but I think we might want to change that. Oh, where are you? Transformers. Yeah, here it is, transformers. Okay. Let's see here. Let's see here. This happens to be... Oh, it may be static. We'll leave that alone for now. We'll set refresh right here. And then from here, we'll then input in the composite right here. Refresh. I noticed that the audio keeps... It's because of the form. I'm going to have to update. I'm going to have to fix this. There we go. Refresh. And then last but not least, we have one more right here. Colorize. In this case, we will also add in refresh. There we go. Oh, there we go. Okay, we've added that in, so now we can refresh. All right. Now, currently we have warp, show, and colorize. I think show should be, because the whole idea behind colorize and warp being separate is that we can modify it separately, but I think maybe we should actually put it in here. I think that's what we probably should do, is actually put the warp, instead of making this its own separate file, we should just put warp here and then add it. So one thing to do is we need to, for the sequencer, so we have our animations. It's this right here. It's going to be a dictionary with our components followed by a list. We probably should, change this a little bit. Here, where is animations used exactly? I think it's not used very much. It's not used very much. And we can easily update. Yeah, I think that's the key point here. When we do get frame, we should add. So yeah, instead here, so we need to add in a loop here. But another to do, what we need to do is add in warping or colorization, so that when we call for get frame and we want to warp it, we can. part of me feels like we could easily just part of me feels like we could easily just do a bunch of if statements, but that will decrease processing power, and I don't really want to do that. At least not at this point. I wish Python had switch cases, because if Python had a switch case, that would make things kind of a lot easier. Yeah, we're going to combine show. These are going to get all put together into one. So if that's the case, that means we need this file here. We're going to put this right here. If warp, do this. There we go. And where is, oh yeah, data. And in this case, we'll call this warp data. We'll put this also before refresh. So warp data happens to be this happens to be an ND array. And this happens to also be none. There we go. Okay, yes, and please oh, and please add it to the doc string. Thank you. Okay. We'll have to organize the doc string in a bit. But that means warp here is done. We're not doing that anymore. There we go. Next on the list is colorize. If you notice, colorize is kind of the same. We're creating a copy and then we're just simply modifying the color. So we'll simply put that here as well. If colorize, then we're going to do this. I think we'll colorize. Actually, when should we colorize? I'm going to change this to color here instead of colorize, if color. Now where, yeah, here it is right here, color types. There we go. We'll put it right afterwards, like so. Like that, and we probably should that, and we'll move that there for now. There we go. Keep it all in focus. So let's see here. Let's see here. Okay, let's continue. Let's see. Hoo. Now we have color. Then we can get rid of colorize here. If we wanted to, we could still keep them. Actually, if we wanted to, we could still keep them, but it doesn't really matter now because it's all under show. So let's see here. And I'm going to do colorization first. That way I don't have to mess with any, because warping it will change a lot of the pixels. And yeah, it might end up, I might end up messing with the image a bit if we do that. So what we're going to do is we'll do that. And yeah. And the idea would be they'll fully colorize the entire image. Not just the back, or I think the background would also change. So we might need to fix that later. I think there is a potential problem here. I'm going to put that here. To do. Potential problem with background also changing color. But yeah, there we go. Oh, and let's add in color. There we go. Okay, added in color. So with that being said, now what we can do is when we have our sequencer, let's update this real quick. So sequencer is no longer just going to be, the animations is no longer just going to be a dictionary followed by a list. This is actually going to be another dictionary and it'll have strings, and it's actually going to have any. So we'll get rid of framer here. Not Amy, any. Because the idea here, and last but not least, we need to put down some consts. So we'll have, these are, oh, actually, because these are, well, yeah, the sequencer is the only one that's going to be, the whole point of animator is just going to be get frame. So it doesn't have to know anything else. It doesn't have to know any of the underlying information about how the the frame is being generated. It just needs to know that it's getting it. So because of that, these can be constances. So this will be the frame, or so we'll call this the frame list. And we'll call, all right, and this is going to be a string. Oh, this is going to be a final string. We'll call this frame list. And then another one will be the parameter, or yeah, this will be the parameters. And this will be a dictionary of, oh, sorry, this is going to be a string, but this is going to be a string, but the parameters that is going to be input is going to be a dictionary and such. So this will be parameters. And we need to standardize this. Parameters, there we go. All right, yes. There you go, final, there you go. Okay then, so now we have that. Let's go down to, so let's see here. Let's go down and start fixing this up a bit. So what's going on here is a very simple, let's see here, add emotes. We're going to copy this into the emote, and then if dir path, then we're going to look, yeah, here it is. You can see right there, parameters. So this is what we want to store, is the parameters path. If we have it, then we want to save it. So I think the first thing we want to do is, yeah, if it's default, then what we're going to simply do is create a copy in a dictionary, and we will simply call this, there it is. This will be frame list. Actually, what's the default dictionary look like? Our default dictionary is, yeah, that's different. That's going to be different now. Yeah, that's going to be very different now. Yeah, that's going to be very different now. All right then. So let's see here. We have animations components. Originally we were importing in the default dictionary. This is just, let's see here, animation components. Yeah. So in fact, this isn't a frame list. This is the components. So yeah, so this should be called animation components. Yeah, animation components. And I'm just going to call this, I'm just going to continue. I'm going to continue with this animation component. We can rename it later, but yeah, animation components. Yeah, it's just the different things, and then the framer with the, oh, actually that makes, okay, let's go back. Let's go back. 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 Oh, no, 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 no. That's fine, that's fine. That's fine, that's fine. This is fine. There we go, that's... Come on, come on. Here. So yeah, right here. This is where so it's here, the list of framers. So default dictionary. So that's what we're here. This is our default dictionary. So ultimately we want to change this here. All right, I'm making sure that everything is making sense. So we're not changing the default because this right here, this should be different. This should be a dict string any now. Yeah, that should be a dict string any, and yeah, that is correct. And then down here, once we call, we create a copy, and then that's the end of it. But if we load the animations, then we simply, or originally what we were doing was we were going to load the directory components and then put it into emote. So technically we need to modify load directory components right here. This is where the parameters should be stored. We actually have parameters here. And then here is where we're going to get them. We input them into the sequence. Actually, yeah. I think this is the modifications for the layers, these parameters. Yeah, these are the for the different layers, aren't they? We load the image sequences, we get the parameters. Yeah, that's exactly what it is. This is for the different layers. These are the parameters for the layers. But if that's the case, then what about the parameters for the frames? So we would have to rename this to make it a more, because we'll have to rename this. So let's go ahead and rename this to layer parameters. And then afterwards, we should have a new one also called sequence parameters. And in this particular case, yeah, this will be the sequence parameters. Or it doesn't need to be a dictionary, does it? I don't think it needs to be a dictionary, because this is all about the sequence. So this just needs to be a list. Yeah, this just needs to be a list, but not just any list. This is a list of ND arrays. And yeah, we'll import numpy. And the idea behind that, there we go. Yeah. So here we're storing the layer parameters. So if the layers, because the idea of load components is to make it easier for us to load up sequences. Let's see here. So load images to sequence is done right here. And we end up importing in our sequence. See, there's our sequence list. Let's see here. That's our sequence list, the RAR path. Layer parameters is Okay, I think the nomenclature is coming back to bite us, because now that I look at it, these parameters is actually the sequence of the images. It's not actually the parameters being pushed down the ladder. So this is wrong nomenclature. This is the layer sequences. Or not even layers. This is the animation sequences. That's what this is. So if we have animation sequences, then what we do is we will get the sequence, call it IDX, and then we will load it in which case we will then define said sequence. So yeah, that's the sequence list. We can still keep the parameters here because we still need to modify them. Apparently, if I remember, originally we were saying that if we go this high up in the levels, we weren't going to bother pushing all of the changes down because it would just be too complicated. So if that's the case, then for the layer parameters here, we can still keep it in when we define the sequences. We're returning components right after we do this. So that pretty much means that it's this components here that needs to be modified. So here we can see it's an iterator with a framer. This way we can continually cycle through. And in this particular case, this is going to be changed to a dictionary any. Yeah, it's going to be changed to a dictionary any. So we'll change this to a dict. And this will be a string with an any. There we go. There we go. And then as for our sequencer, you can see it's a list framer. There we go. So yeah, that's still a list framer. So that we are keeping an eye on that. And then here we go. So now this is where we are. This is going to be a list of ND arrays, which which is pretty much telling me that they are the different ways that we're going to warp an image. So with that in mind, this needs to be in a, we're going to define this here. This will be self dot, let's see here, where is it? It should be a nice big, something like animation, I don't see it, to the top. Oh, wait, is that because it's under framer? Oh, I bet it is. I bet it's because it's under framer. Let's see here. It's under... No, it's not. Where is it? Where are you? Where did I put it? Oh, did I just... I did. I accidentally removed it because I was worried about it. So we need to add them back. Animation. Let's see here. Animation. Animation iterator. All right. Final string. We'll call this animation iterator. Oh, and then the other one was simply, this was parameters. We'll call that. We'll keep it that for now. Oh, no, we shouldn't because we're messing it up. So we're going to call this, we'll call this image parameters. There we go. And this will be a dict, which will be a string. And I said an ND array, but if you think about it, there are a couple different parameters that we can have. So this is also going to be an any. Because the idea behind this, we'll call this image parameters. And this will be a final. Oh. Yeah, I always want to set it here, but that's not the case. We're not doing that here. Oh, there we go. Import that in. I need to make sure that I type it correctly. Oh, there we go, parameters. Now let's head on down. So where is the that I just made? Here it is, right here. So this should be animation iterator right here. And then, let's see here. It's in our for loop. We're building our components, which means this should be... this should be also in our... Let's see. Let's see. Let's see. The main thing is, how is this going to work? So if you look here, we have our animation components followed by our list of integers. So we probably should generate something similar to that. Oh. Yeah, this is where it gets complicated. This is where it gets very complicated, because theoretically, to me, we should combine this. Instead of calling this, again, back to, if this is animation sequences, this should actually be called... Now we're looping back around. Animation parameters. Animation parameters. But instead, this time, we have the... instead of this time, it's going to be a double... Yeah, it's going to be a double dictionary. Yeah, it's definitely going to be a double dictionary. Which would be a bit annoying, but... Oh... Well, this technically is... Oh, this technically is the top layer, like the most highest layer. Because if we wanted to, we could simply just load the sequence here with no problems and then call it a day. And we're trying to track the warping functions because when we call get frame, we want to... If there's anything we're going to warp, we want to do it then. So yeah, so because of that, that means... that means, yeah, we do have to do it somewhere around here. Or here. We run load frames, this right here. We then get our sequence. From here we can then import it in. So that is fine. And then next is to add in the parameters for the list, which means theoretically we would have to incorporate it in. So, and plus it will be a list of, yeah, the best way to think, what would be the easiest way to do this? To me, the easiest way would be just to store it in the frame. Or, as I said, store it in the sequence. I think what I'm thinking is going to work. So we'll do this. This will be another dictionary. This is going to be a list of anything, really. So this is going to be a string with an any. And then now instead of just a get animation components, let's see here. So if there are animation parameters, let's see, we could probably... so let's see. Part of me feels like... would have... These are going to become globals in a second. Yeah, these are going to become globals in a second. I might have to write a function which will say define parameters, and then it will generate out a thing that people can then fill in. Because this is getting very complicated, even though I'm trying to keep it as simple as possible. Alright, so load directory, yeah, here it is. So the idea here would be getting this component, and I'm going to have to create a dictionary get value something like that in order, because I don't want to keep doing get, get this, get that. A double get does not seem wise. It seems like it's going to be very prone to errors. It seems very so let's just hokey it. It will complain at me. So animation components, and then this will be the animation iterator. And then we'll put parameters here. And then we'll do the exact same thing again. But this time, it will be parameters. There you go, image parameters. And we'll put down image parameters right here. Image parameters. So we'll keep the nomenclature the same. Now that we have this, we have our what our parameter is going to be for our particular component. Let's see. Yeah, so I think this might work. And then from here, because this parameter is going to just be a numpy array. So from here, we can then simply put in, oh, this is our, technically, this is our animation iterator right here. Let's see here, I'm looking, animation components. We're making a sequence. This right here is the sequence, right? This is what we generated. So I think that's where it lies. Because we're creating a cycle of the sequence. When in actuality, what we should be doing is putting these together. Okay. Let's see here. Yeah, we should be putting these together. It should be a list of Yeah, I think I have an idea. It's involving zipping the sequence with image parameters. Like so. Yeah, like so. And then we proceed to, we zip them together, and then, but that's another iteration. So that's not going to work. Actually, let's see. Man, this is actually a bit complicated. Yeah, this is a bit complicated. It really depends on how we define it. So let's go to self. Let's see here. Actually, it should be, what was our builder called? We called it sec. So let's go to sec. Sec.animations. And then let's go ahead and grab one of our sequences. We're going to let's go ahead and get a animation emotion, and we'll get happy. So there we go. And as you can see here, this is our animation happy. You can see we have our different components, the intro, the talk, and the idle. And then when we go over here, you can see that these are iteration tools. So this is the cycle. And then pretty much whenever I call this, it will just immediately produce the cycle. What I'm trying to do is I'm trying to force in parameters into the iteration cycle so that when we get to it, if the iteration cycle happens to have a parameter, then we apply said parameter. That is what I'm thinking. That's what I'm hoping to try and do as well. But I don't know if that would be possible, because we're generating a frame here, and I could zip them together. I could theoretically zip them together and then But a zip is just generating a list. Maybe that might be the course of action. That might be the course of action. So let's try something. Let's try something. So we have ourselves a sequence. Let's see here. I don't think, yeah, we don't have that actually loaded, but we do have our good friends here. Let's get idle. Oh, animation components, idle. So there's our iterator. We'll just simply, oh, it's a cycling iterator though. So, let's see here. What's the length of this? What is the length of this? Oh, there's no length. Okay. It's because it cycles. Yeah. Yeah. Because it cycles, it's going to... Okay. I think... Yeah, because we make it a... Because we turn it into an iterator, or... Well, actually, I think at this point in time, it's not one yet. So, let's go ahead and do this. So let's go with sec.load images. Oh, let's see here. Yeah, it should be. Oh, yeah. We need to go to sequencer. Sec.sequencer. Oh, yeah. Come on. Sec.load images to sequence. And we'll. Let's see here. What's our dir path again? All right, so happy. So we'll join path. And we'll set to idle. There we go. Okay then. So why don't we do that? Sec.load images to sequence. There. And we'll set the sequence to 01012. And let's see here. Sequencer has no attribute. Did you mean load images to sequence? Oh, I typed that wrong. Oops. Sequency. There we go. Okay. So there's our list. Right there. We'll call this BB for now. So there's our BB. There we go. Nice and loaded in. It's not a sequence. It's not a cycle yet. We haven't did that yet. So now we have that. Let's set the image parameters. To make things simple, we'll call this CC. We have 5 frames, and we're going to make them all none. So that. There it is. So now what we're going to do is we're going to zip BB and CC. That'll make us an iterator. And then I think what I'm going to do is, because it's zipped, we're going to parse it out. So we'll go with AA for AA in zip. Like so. And then we will cycle it. So itertools dot cycle, and then there, and oh, what do you mean itertools is not defined? All right, import itertools. All right, there we go, and there we go. Then there we go. We link it together. Now, because of that, instead of just doing this type of loop, boy, this is going to be. Yeah, it's a good thing that we're not building it as we go, but this is going to be a separate thing because this would take a lot of processing if there's too many frames. But the idea here would now be, we generated the sequence. So we generated the sequence. We have our parameters. And I think we're going to have to do something about that loop. Yeah, we're going to have to do something about that loop. But nonetheless, this right here is now going to be This is our new sequence right here. All right, then. Oh yeah, oh yeah. So there we go. So that's our new sequence. It's obviously broken. It's obviously very broken. I mean, it's very, very broken. And also, we're not actually outputting out a dictionary any. We're still outputting an iterator. So we should switch this back. This is still going to be an iterator. It just so happens to be an iterator of a tuple now. All right. Yeah, this just so happens to be an iterator of a tuple. And then from here, oh yeah, this doesn't like this, but let's see here. So we can actually go back to just iterating this. We don't have to worry about that, like so. All right then. So theoretically, this should work. It's horribly broken because of the fact that if there's no image parameter, then this is going to crash. However, because it's combined with animation parameters, because they're linked to the animation parameters, we're going to have to make something ugly like a double... Oh, I know. Yeah, we're going to have to do a double if statement. So we're going to go if this. We're going to grab our parameters, like so. Actually, I should probably say if not, but if the parameters, then... No. Let's see here. Let's see here. Let's see here. Animation parameters. Yeah, if either or is missing, then it's going to throw an error. So that's not going to be work very well. And likewise, this should be... This is going to be kind of like a none. This, however, is going to be a list of ND arrays. So this is going to be a list of ND arrays, and that's what we're going to be inputting in, hence why the way it looks. We define our sequence, we define how much is going to warp before said sequence, and then it populates the data. So, sequencer is fine. It's really that one. It's really that one. All right. Let's... If sequence, not sequence, if image parameters, then we do this. Else, this is ugly. We are going to change this. Actually, that's let's see here. Else, it will be kind of the exact same thing. Yeah, this is ugly. This is very, very ugly. And then we'll have a none times by however long sequences. And we should probably put this in a like that. There we go, like that. Yeah, that is horribly ugly. What's it complaining about? We got a... Oh yeah. This is going to be... Let's see here. Where is this error? This sequence is going to be iterated into this here. So components is right here. Okay. So yeah, this is now going to be a tuple. This is now a tuple. Well, actually, it isn't. It's actually an iterator of a tuple. So what's the complaint? Let's see here. Expected list framer. Got list tuple. Let's see, got list tuple framer none. This is supposed to be a... Oh, is that? It's because we're overwriting this this file here. So I guess we'll call this the this will be called the sequence tuple. That way we're not overwriting any of our previous info. And we'll put that in there, and there we go. Okay, nice. So theoretically now, later down the road, we should be able to modify our parameters. We'll test that next time. I need to stop. I need to stop streaming. I have stuff to do. I have stuff to get done. But it's been fun programming. We figured out the animation frames. We can now produce an animation. And we have updated a lot of the framer and animator. And we've actually learned a couple other things, particularly how Python works. So with that being said, I'll continue later. Until then, it's been fun. It's been fun. But yeah. See everyone tomorrow. Laters. Ooh, and hopefully we'll have this done soon. Anyway, laters.